Hi everyone, welcome to the Generative AI learning series by StarAgile. In this series, we'll explore generative AI and understand how it is changing the way we work and create. If you're just curious about AI or want to learn more, you are in the right place. I'm Huzefa and I will be your guide throughout this journey. In the first chapter, we'll explore the basics of generative AI and agentic AI. This is a great starting point to learn the basics about the same. So let's dive in and get started. In this session, let's start by talking about what is Gen AI and Agentic AI. We'll break down these two buzzwords and introduce these concepts to you in detail and see how they are powering modern intelligence systems. So talking about what generative AI means. So this basically means that an AI is used to create new content such as text, music, videos and images based on user inputs. If you have interacted with tools like ChatGPT, DALL-E, etc., you already know how these tools work. Let me give you a quick demonstration of one such tool known as ChatGPT. So here you see I'm using the website for ChatGPT called chatgpt.com. This website is free for use, right? So you can create an account on this. You can use your personal email IDs and create an account on ChatGPT, and you have access to a lot of features straight out of the box. You do not need to purchase any subscriptions for this. So here in this interface, you are basically given a chatbot to answer. In this interface, you are basically given a chat box wherein you can give your own instructions. So let's test it out. So here I want to ask the system, what is the latest news around generative AI? So as you can see, I have given a user prompt to this model, and beyond this, I have not said anything. So let's see how this tool works. So when I'm hitting enter, at the back end, the generative AI model is going to take my user prompt and it's going to create an output. So here you can see it has given an end-to-end summary of what's the latest news around the domain of generative AI. Starting at the top, it has given us some of the image references to look at, right? So these are some of the latest AI trends in 2023, followed by some of the roadmaps that are followed typically by anyone who is wanting to learn. So you can reference these images. Apart from that, you can see there are some new policies and regulations that have been come up, industries and experiences, what are the news around the acquisitions and things like that. So as we can see, all these content has been generated based upon a single user input. What's going on at the back end, that is what we are going to understand going forward. So other than ChatGPT, there are other tools out there. So ChatGPT is generally used for creating text, right? So ChatGPT is mostly used for generating text, but you have other tools like DALL-E, which is used for generating images. DALL-E has also been developed by OpenAI itself, right? So this tool was created by OpenAI, and initially it used to have its own website, but now it has been integrated within ChatGPT itself. So you do not have to go to another tool to use DALL-Es for creating images. You can directly use ChatGPT's interface only to generate image content as well. If you want to create audios, you typically go to tools such as Suno AI or 11 Labs. And for video generations, most commonly used tools are Runway ML. Right? These are some of the examples of currently popular Gen AI tools out there. Let's also see how images can be generated using ChatGPT as a reference. So if I go back to the interface, you can see here, I'll go back to the home page once. Right? So here you can see at the bottom, there's an option to create an image. So when I click on this tool, it's now waiting for me to give a prompt for creating an image. So let's give an instruction. Let's say we give an instruction such as create an image which showcases the latest trends, the latest tools used for generative AI. So here I have given a user instructions asking the model to create an image that can showcase all the latest tools used for working with generative AI. Let's see how it is doing after the user prompt is processed. Alright. So as you can see, this image has been generated by ChatGPT's DALL-E model at the backend. And what you can see, it lists down all the modern tools that are currently used, right? So you have ChatGPT, which we are currently using. Then Gemini is a model developed by Google, which is similar to ChatGPT, but it's solely developed by Google from end to end. Apart from that, we have DALL-E, which again I spoke about. It was a model generated meant for creating images, which was developed by OpenAI. Now it has been integrated within ChatGPT. Then Copilot is now bought by Microsoft and it has been integrated within GitHub. Now the best part about Copilot is it's mostly used for code generation. So if you are a developer who is used to writing programs, softwares, etc., and you need a tool that can assist you in writing more accurate programs much faster in a much simpler way, Copilot is a great tool that has been integrated already within GitHub. Likewise, there are Cloud and Midjourney as etc. So there are hundreds of tools out there, but these are the most popular tools that are currently getting used. And as you can see, we have seen two examples right now. In one, in which we saw how text is generated as an output based upon a user input. And the second example in which we saw how image can be generated as an output based upon the user inputs. So this is what generative AI means, wherein an AI model is used to generate new content based upon single user inputs. Now you might be wondering how these models work. So the powerhouse of generative AI at the backend are machine learning models known as large language models or LLMs for short. So these models, they have a very famous acronym which is known as an LLM or large language model. So LLM, this stands for large language models. And these large language models, they are sophisticated machine learning models which are trained on massive amount of data sets, right? So these models are trained on billions and billions of data points until they are sophisticated enough to understand the natural language that we use to communicate and then use those to generate new content. The most common way of training these models is to predict the next word based upon the current context. So if you are used to using or chatting using Google keyboard on WhatsApp or emails, nowadays what you have observed is that when you start typing, the keyboard itself will start suggesting you the next word that you are most likely to click. That's a very simplified example of how LLMs work. LLMs are much more powerful and much more context aware as compared to what happens in Google keyboard, but you get the context of where am I going from. So basically, just like how in Google keyboards you can easily predict the next word based upon what you have typed previously, LLMs are also trained in a way that allows them to learn what should be the next word based upon the previous context that has already happened, right? And they do this for millions and millions of iterations until they are sophisticated enough to work on their own, right? So until they are context aware, until they know how to interpret the language, what are the building blocks of exactly structuring an output correctly, until then you continue to train these models, you keep feeding them more and more amount of data, and eventually there will come a point wherein they are good enough and sophisticated enough to generate a decent user useful content, right? So the powerhouse of these generative AI models are large language models. Sorry. So the powerhouse of these Gen AI content is large language models. So before going forward, let's take a quick demonstration of how you can interact with large language models using Python. Okay. So in order to get started, what we need to do first, we need to install a few dependencies. Okay, so make sure you have a couple of packages installed first. The first package which we want to install is known as OpenAI. So this package called OpenAI, it's a Python SDK which is developed by OpenAI itself, and that allows you to work with the large language models like ChatGPT and all within the Python's programming interface. Okay, so you can easily install this package by running the pip command. You can just type out pip install OpenAI within your virtual environment that you already have created, and that will basically install the package and the required dependencies around it. So I already have it installed. So what I'll do first is I'll start by importing the necessary libraries. So we'll first import the package of OpenAI. So here you can see I have imported the library right here. Once imported, the second thing that you need in order to work with these models is an API key. Consider this API key as your authentication meant to give you access to the large language models. So you can generate your own API keys from the OpenAI's website. Let me show you how that works. So if you go to Google and just type out OpenAI API key, it will give you a link to the website from where you can generate your own unique API key. So this is a secret that is meant just for you. It's not recommended to share these API keys across different people. So here you can see this particular platform, this interface will be shown to you once you are signed in. And as I mentioned, you can create your own free account very easily on this platform. Once you have signed in, you can click on this button here to create a new API key. You can give it any name that you wish for. So here, let's say I give it a name, StarAgile demo, right? I can give any API key name here, and based upon this name, it will basically create an API key that is unique for my account. You click on this create secret key option, and it will show you the API key. Now, here, once this key has been shown to you, it's mandatory for you to copy this key right here and there, okay? Because once you click on done, this API key cannot be shown again, okay? So once that interface is gone, you will have to, if you have not copied it, you will have to delete it and create it again. So make sure that interface that was shown to you to copy the key, you copy that key then and there. And once you have copied it, you go back to your virtual environment, right? You go back to your project directory and you create a file called .env, right? And within this .env file, you have to paste your API key that you have created, right? So whatever API key you have copied from the website, you paste that API key within this .env file. Okay, you have to paste that particular API key here, right? And you can keep this .env file anywhere in your project directory. Typically, it's kept at the root level of the project directory. So within your entire folder, right? So you typically keep it at the root level of that directory. So as you can see here, I have kept it in the root folder of my current working directory, right? And automatically this .env file will be loaded so that now when you are working with OpenAI, the first thing that we will do is we'll read this API key which is present in this .env file. Now currently you are seeing this particular API key when I'm sharing the screen, but by the time this video is out there, this key will be deleted and it won't be useful for you. So make sure when you are following, you create your own secret API key and not share it with everyone. Anyways, so continuing here, I'll close this. The second thing that we want to do is we first want to load this API key in our working environment. So for loading API keys or for loading any environment variables, the package that is typically used is known as .env. So this package is generally already available in Python installations. If not, you can just run the command pip install .env and you will get this package working for you. Now, so once this particular package has been loaded, you can run the command .env .load.env command. And what it will do, this particular function, it's going to scan through your folder directory and try to search for this .env file, which we have already created. And within this .env file, all the environment variables that have been defined, those environment variables will be set automatically for you to use, right? So here, we do not have to worry about setting the environment variables manually. Once you run this function, these environment variables will be readily set for you to use. You do not have to worry about setting it up on your own. Okay, so you run this function and you will see the output contains true, meaning that the .env file has been successfully loaded. Okay, so now we have loaded our environment variables. So now what we will do, we will read those environment variables for us to use. So now what we want first, we want our API key available to us. So for using our API key, we need to import a module called OS. This is a Python package used for interacting with any operating system level details, right? So if you want to print all your environment variables, or if you want to get a certain environment variables, we generally work with the OS module. Now what we will do is we'll basically get our API key by using os.getEnv function. And here we'll say I want the OpenAI API key. So what this will do, this particular function, it's going to scan through all of my environment variables, and it will return me the environment variable value corresponding to the key of OpenAI API key. Now you can print it and check it if you want to, right? So this is the same API key that we had created, and we have stored it within this environment variable. Now you might be wondering, why did I create this environment variable file and paste this particular API key inside this file and not just create a string here that contains my API key? The reason being, for the purpose of security, you do not want to share your API key with everyone. So generally, if you are developing any code, you are developing any softwares, you generally have to commit these softwares or commit these codes to a central repository from where anybody can fetch those particular files. And in doing so, they will also get access to the environment variables that have been created by you. And as a result, that would result in your account being accessed unauthorized way by multiple different people. So if you want to avoid such issues, we generally recommend to make sure you have a dedicated .env file which contains all of your secrets, and load those secrets at the runtime within your environment, within your code at the time of code execution only. So that prevents your API keys from getting out there for everybody else to use. So when I do it this way, nobody has access to what the API key I have created. Only I have access to those keys, right? So as you can see, I'm going to use this API key now to interact with the OpenAI package. So we are set now. Now we are going to import our OpenAI module. From OpenAI, what we want to do next is we want to create a client that can allow us to establish a connection between the OpenAI backend services and my Python service. So what will I do is I'll basically create a client here, which is OpenAI dot OpenAI. And here, when you use this particular class, you need to provide the API key that you have already created above, right? So I'm going to pass my API key right here, so that I'm creating a client over here that can interact with the backend OpenAI services very easily. Now I have my client available that can allow me to interact with the backend OpenAI services. So once you have established your client, now you can use this client to send user responses or user prompts to the any model that you wish to work with. So here we are going to give a simple demonstration of how that can be performed. So let's create a response variable that will contain my responses, and I'll say client.chat.completions.create. So here we are going to use the from the client side, since we want to chat with a particular model, that's why I'll use the chat attribute, and this is the syntax that you have to follow. So this basically is the series of variables that you have to call in order to get to the final variable that, or the function that allows you to interact with the final model. Now within the create, what you need to pass is basically the messages that you want to share. So what these messages are basically your input prompts that you want your backend model to process, right? So let's say you are interacting with GPT-4o or GPT-4o mini, any model, any large language model out there. So we want to pass a certain message to that large language model to process. So if you remember the ChatGPT interface that I had shown you, so these were the messages that we were passing over here, right? So these are the messages that we are creating, and these messages will be processed by the backend model here. So you can see the current model that is used is GPT-4o, but there are other models available as well. So all of these models are available for you to use. You can pick any model from this list, And whichever model you are selecting, this model is going to process the user input that you have processed. And all of these are individual large language models. There are different large language models available. You can read more about them by going on the OpenAI website and see what each model is capable of doing. I'll not go into too much details there, but all the list of available models are there on the OpenAI's website. So let's go back to our code. And since we want to create a set of messages, so what I will do is I'll call the messages attribute, and the messages here is basically a dictionary containing it's basically a list that contains a series of the interactions that are happening between the model and the user. So over here we need to define the messages in a certain order. So I'll explain this after writing the syntax first. So let's say we basically mention that this is a, so here role is user and content is, let's say we'll give it any content, let's say tell me say who is the current CEO of Tesla. Tell me everything, tell me about all the other startups which has been founded by them. So as you can see, what I have done here in this particular function, I have passed a message. Message is basically a list of interaction. We'll cover more about messages in just a minute. But what you need to understand here is that within the messages, you need to pass two things. Messages contains your role and the content. Now we'll dive into role much deeper in a second. But over here, what we are asking the model is to process this message from the user's perspective. So I am a user who is currently asking the model to generate some content for me. So the model is going to look at this content in order to help the user get their answers. So the role here is a user role which is used for generating responses for the user queries. So whenever you are asking the model to generate some answers for you, you are needed to provide the role as a user role only. And the content is going to contain what content you want the model to process. Okay, so what will happen now is basically this particular function, it's going to call the backend, right? So it's going to call the backend model, and the backend model is going to process this message and give the answer corresponding to this particular message over here. So let's run this function. Okay, sorry, I missed out on providing the model key here. So we'll also need to give what model we want to process. Okay. So over here, we also need to pass in which model we are using right now. So I'll also give the model criteria. So here we'll use a model. So you can see here, these are all the different models that are available for us to use. So we also need to mention which model we need to use in order to generate the queries here. So here I'll say GPT-4o mini. You can use any model available from the list. GPT-4o mini is faster. So hence I'm using this model, but you can choose from the list of available models out there. It's going to take a couple of seconds for it to run. Just give it a minute. Right. So now we have the response back from the model. Let's see how the answer looks like. So in order to get the response back, in order to see what the model has responded, so you need to, so if you directly print the responses, you get a lot of different things within the response body itself. You get a unique ID for your chat. You get much more information about that. But what we want the message that has been returned as the output from the model. So here I'll say response. Okay, yeah, within the response, we have to use the choices attribute. So response.choices. And within the choices, we have the first choice, that is the one that we wish to use. So model can return multiple different responses. You need to choose which response you need to get. So over here, we just have one response that has been returned back to us. The choices contains all the, so basically when the model is generating the output, it's not just going to return you one option, it can return you multiple options to select from. So it's completely up to you which response you want to use out of all the available returned responses. So over here, we just get one response. So therefore, I am accessing whichever response is the first response in the list of choices that have been given to me. So I'll say response.choices at the index of 0, and within this I have the message attribute which I can look at, right? And I can print it so that it's much easier to look at, right? So you can see here, and message has the content available within it. So I'll say message.content. So as you can see, this is basically the response that we have received back from the model. So this entire response is generated by the model which we have mentioned, that is GPT-4o Mini. And you can see as of October 2023, the CEO of Tesla is Elon Musk. He co-founded Tesla and so on. Apart from that, these are the list of other startups that have been created by, that has been established or founded by Elon Musk. Right. So all of these are startups that have been created by Elon Musk. Now, one thing that you will notice, and it is very, very important to note here, is that the models that you see, they are not getting trained as we speak. These models have been trained up to a certain point of time. The training was stopped and then it was released for public use. So what you see here is that this particular model which we are using, that is GPT-4o Mini, this has been trained up to the data corresponding to October 2023. So whatever responses it is generating as per the database that has been trained up to October of 2023. Right? So you will always find these things in the responses which tells you where exactly the knowledge base of this model has ended. So after 2023, if Elon Musk has founded something else, the model is currently not aware about what Elon Musk is doing as of today. So this is one of the drawback of generative AI as a standalone tool. We'll talk about how to overcome these using agentic AI in just a second. But this is a very key important thing to keep in your mind, that these models have a threshold on the amount of data they have the knowledge of. So they are not getting trained as we speak. They do not continue to get trained on newer and newer versions of data. So this model has its training stopped in October 2023. So whatever you see, it's basically only until October of 2023, right? So this is basically one way of using these models within Python, right? So you do not have to always go to ChatGPT to get your responses. If you wish, you can easily install the packages, create your API keys, and then use this particular functions to call whichever model you wish to and assign the corresponding roles as well. We'll discuss these roles in detail in just a minute. But the key takeaway from this particular notebook are two things. First, you can use the package called OpenAI to interact with the models released by OpenAI. And second, these models, they have a limited knowledge base. As of October 2023, this model do not know what is the current the current startups that have been founded by Elon Musk. So one thing that you would notice here is that we haven't had an interface like the GPT interface, right? So right now we were continuously interacting with the model, right? So model was telling us something, we can ask the model to further fine tune the instruction or do something else. If you wish, you can also simulate since this particular interaction within your Python code as well. So if I want, I can take this client and I can even interact with it how we are interacting with the ChatGPT model over here as well. So let's see how we can perform that particular activity using Python's OpenAI package as well. So for this particular demonstration, let's create another client. So let's call it client 2. This client also will be created using the OpenAI package itself. Right? Again, we'll pass our API key here. You do not need to create a new client. In fact, I can use the same client as well. So, but for this demonstration, let's create anyways, it doesn't matter. Okay, and just like we did over here, we first need to start with the messages, right? So let's create we'll use the response here, and the response will be generated using the second client. So client2.chat.completions.create. Now within the create function, you need to pass your messages. So here again we'll set our messages over here. Now messages is basically a list that contains the individual messages that you want to pass to the model. So we'll start by passing the first message. So over here I'll do things a little bit differently. So a lot of times you want your large language models to behave in a certain way. Say for example, you are working in the healthcare domain and your goal is to do certain research, or you want to identify what's the latest drug that has been developed for any cancer treatment or something like that. So in such scenarios, you want your responses tailored in a way that a professional medical researcher would respond. Or let's take another example. Let's say you are doing your research on weather, like weather forecasting or something like that, and you want to know what's the current weather in your particular location, or what the weather forecast looks like on any given location. So in such cases, you want to tailor your responses on how a professional weather forecaster would basically respond to any of those queries. So in such cases, you can actually define such roles to the large language models as well. So if you want to perform such activity, let's see how the message interaction would look like. Okay, so whenever you want to assign any certain role to a large language model, the first thing that you have to do is basically set the role keyword to a system. So the system role basically assigns the large language model the idea or the behavior or how it needs to respond to any user messages that are followed up. Okay, so in this particular case, within the system message, you are basically going to pass the content that says, let's say you are a travel assistant that provides friendly travel advice. So what we are doing right now, we are basically asking the model to behave as a travel assistant that provides friendly travel advice. So in this particular case, the model knows it needs to respond as a friendly travel assistant. Okay, so that is basically what we are saying in the first message. After the first message is set, after model knows, okay, it needs to behave in a way how a travel assistant would behave. Next up is basically the role of a user. And within the user role, I will ask the model some things that I want to ask as a travel enthusiast. Okay, so let's say I'll pass the content over here, and now let's say I ask the model, I am planning a trip to Bali next month. Can you please suggest a travel itinerary for 7 days? Okay, so as you can see, I have passed two messages. The first message is basically at a system role which tells the model that they need to behave as a travel assistant which is giving friendly travel advice. And the second role is of a user role in which I am asking the model to help me plan a trip to Bali, right? So as you can see, the next message that is followed up is expected to give me a friendly travel advice on what I can do if I want to travel to Bali. So let's run this particular function, and again we need to pass the model that we wish to use here. So here we'll use model as again GPT-4 meaning. Minute, 1 second. Oh, sorry, there was a spelling mistake here. So give it a second, it will run. Now the model has generated a response. Let's see what the model response looks like. So just as we did previously, here also I am going to print the response that has been generated by the model itself and see what content has been generated by the model. So as you can see, being a friendly travel assistant, this model has created a day-wise travel itinerary for me, which I can use if I am traveling to Bali. Right? So as you can see, this is a detailed travel itinerary that has been created by the model itself. And now what I will do is, it's not just the end of the interaction. If I want to make any changes to this current itinerary, what I will do is I will ask the model to look at this itinerary and provide the changes to it as well. So for doing that, let's store this in a variable here. So I'll basically take this entire response. Let's say model response 1. And now what I will do, I will basically go back to the client that I am using for interacting. Let's take this client again, and this time I'll append a new message. This time the role of this message is going to be an assistant role. So the purpose of an assistant role is to allow model to look at the response that has been generated by the model as an output for your previous user input. So in this particular case, the first user input that we had given was to plan a trip to Bali, and based upon this particular input, the model has given us a certain output which we have stored in this variable right here, which is this model response 1. So I can give this particular value back to the model to look at it and say that, okay, this is what the current response looks like. Right? So the content for this value is given by model 1 response, right? And I can again pass another message with a role of, let's say, a user, and ask the model to make some modifications to my previous itinerary that was retrieved. So let's say itinerary looks too hectic. Can you modify the same and make it a bit more relaxing? Right? So now what model will do? Model will start by looking at the current response that has been generated, and it will modify this response based upon whatever new input has been given by you. Let's run the same and let's give it a couple of seconds for it to process. Now the model has been responded. So let's see what the output looks like. Right? So now what you see is basically the model has taken your 7-day previous itinerary and it has basically made changes so that you are looking at it in a more relaxed manner. Let me print it so that it's a bit more structured. So what it has done, it has basically taken your previous itinerary and made it more relaxed as you requested the model to do, right? So now whatever itinerary the model has returned, it's more relaxing in a way and not that taxing for you. Alright, so that's basically a couple of examples that gives you an introduction to what you need to do if you want to create an interaction interface within Python using the OpenAI packages. Now let's go back and understand what exactly we did here. Now remember, we haven't touched upon what Agentic AI does. Right now we are using, or we are looking at just the generative AI before Agentic AI. So before Agentic AI was introduced, the interactions that a user and a model did were single prompt responses. What single prompt responses mean? That every time you want the model to do something, you need to give the entire instructions to the model from starting to finish in a single prompt, right? And the model needs to be fed the entire history manually, right? So you need to pass all the instructions as we did here one by one, right? So you see here we managed the entire message history manually. We started off with a system message that assigned the user some role, that assigned the large language model a role. Then we passed a user message. Then we got some response back from the model that we assigned to a assistant role. Then we again passed a second user message. So here we are manually keeping the chat interaction history and we are taking care of the management ourselves, right? And that is basically the manual effort that you have to put before Agentic AI was introduced. So there is no concept of a memory or context, right? So you had to pass everything manually, and there was no automated tool usage in place. Now, what is the meaning of automated tool usages? So one thing that you will note here is that, as I mentioned previously, these large language models, they have a knowledge bottleneck. They do not know what happened after they stopped training. So the model that we looked at, which is GPT-4o Mini, it was trained up until the data for October 2023. It doesn't know what's the latest trends or what's the latest news happening. So in order to get a much better answer, if you're doing some research, you need the latest revolutions as well. So in such cases, it would be better if your model could do a research on your behalf. So imagine a scenario wherein you give a response, you ask the model to do the latest research or tell it what's the latest developments in the field of generative AI. So in such cases, the model can look at the latest released research papers on the internet. It can do the browsing for you. It can summarize what all research papers have been released up until the latest one and give you the summary based on that. And these capabilities are basically part of the Agentic AI framework that we are going to discuss going forward. So Agentic AI solves a lot of bottlenecks that were previously present in generative AI as a standalone field. Right? The first biggest bottleneck that it is able to overcome is automated decision making. So imagine you are now interacting with a travel assistant and you can ask the travel assistant to make the booking on your behalf as well. So now the travel assistant that you are interacting with obviously is a large language model, and it needs to select which tool it needs to call so that it is making the bookings for you. So if you need to make the flight booking, there has to be a tool that allows it to provide the source, destination, time, etc., so that it can make the booking on your behalf as well. Similarly, if you want to know what's the latest weather in Bali right now, it needs to get access to a tool that can return the weather in Bali for next month or next 2 months or whatever timeline it is. So automated decision making, it's basically the first biggest bottleneck that is solved by Agentic AI, wherein based upon your user input, the AI model is going to decide which tool it needs to call in order to get the accurate response back. Second is solving the multi-step reasoning problem. So here you do not have to manually keep a trace of all the interactions that has happened between the model and the user, right? So you just need to pass it your next prompt, your next message. The previous history has automatically been stored by the model itself. You do not need to manage the context that we are currently doing right now within this example that I had shown you. And the third is the tool integrations. So the tools, the example that I gave, I mentioned two tools. One tool that can help you make the flight bookings. The second tool that can quickly check on the weather of any given city. So you can integrate these different tools within your chat interface that can easily give you responses based upon the user inputs. So all these bottlenecks are basically solved by Agentic AI. So now I hope you know the difference between generative AI and Agentic AI. So Agentic AI also is generative AI only, but with some added capabilities and functionalities. What these added functionalities are: the capability of automated decision making that can allow the model itself to decide what decision it needs to take, which tool it needs to call, plus it can keep a track or it can keep the entire memory of the interactions that have happened between the user and the model itself. You do not have to do any of those management yourself. Right? So just to give a recap, Agentic AI is basically a tool that can help you plan, decide, and take decisions using different tools that can be integrated easily within the Agentic AI interface. And in a short form, it's basically proactive, not reactive. So proactive means based upon the user input, it will proactively decide which tool it needs to use. It will not wait for you to tell it, okay, use this particular tool to give me the latest response corresponding to my query, right? So it's a proactive way of deciding which necessary tool to call based upon the user input that has been received. And if you want to break down how the flow diagram would look like for an Agentic AI interface, you as a user would start by giving a user prompt. A user prompt is nothing but an instruction that you see over here, right? So this is basically a prompt that we are giving to the model. So you always would start by giving a user prompt. This user prompt, instead of going directly to a large language model, it would be intercepted by an agent in between. This agent, it's going to look at the user prompt and it will decide which tool it needs to call. So if your prompt is asking the model to check out the weather in a particular city, so the agent itself will decide that it needs to call the weather update tool to get the latest weather corresponding to what the user prompt asks. Right. Similarly, if the user prompt is asking for it to make a certain flight booking, right? So in this, similarly, if you are asking the model to make a certain flight booking, so let's say here you ask the model to book a flight on your behalf. So then based upon the user information, it will call the required tool and give the, let's say, the this boarding destination and the arrival destination, right? And based on the user inputs, the model will automatically help you make the flight booking as well. Right. So here you do not need to be in between this action plan. User prompt will go to an agent, agent will plan the action, call the tool, and you will get the results back, right? So it will process the results and it will respond back with the output that was returned by the model that it is calling or the tool that it is calling. I'll also demonstrate how this tool functionality has been integrated within ChatGPT as well, right? So we're not going to code it right now, rather I'll go to the ChatGPT interface, right? The website of ChatGPT that we have been seeing. And at the bottom, you will see there are individual tools that are available for you to use, right? So here you can see ChatGPT already has a lot of different tools that are available. So if you want to make sure that you are searching for something on the web, so you can call the search tool, and now whatever you are going to type, that particular information, rather accessing the knowledge base of the model will try to research on the website and get whatever the latest information it can find and then summarize the content for you. Okay, so let's say we ask the model, provide a brief overview of the latest developments within Gen AI domain. So now what it will do, rather than accessing the current database that or the knowledge base of the model, you can see it is starting to search the web, and you will now see the response will be based upon the current date. So as of May 2025, that is the date of recording, as of that particular date, these are the latest developments or advancements that has been made in the field of generative AI, right? So at the beginning, whatever the responses were, those responses, as we saw in case of when we were interacting with the model on standalone basis, those interactions were responded based upon the knowledge base of the model only. There was no agent involved in between. But now, based upon the tool usage that we have provided, so what the model is now doing, it is researching the web, it is going on the web, trying to extract all the latest and available news on generative AI, and then summarizing whatever it can based on the outputs, right? So the tool will give you certain responses. Those responses will be fed to the large language model, and the large language model will summarize those content for you. Right? So in this particular case, you will now see we are getting the responses as of May 2025. That's the latest available news in the domain of generative AI. Right? So you can see OpenAI has released a couple of models. The Google's DeepMind's Alpha Evolve has also released, right? XAI, or so this is Twitter's or Elon Musk's own startup for creating a large language model called as Grok. So that also has released a new version of the model called Grok 3. So all of these are some of the latest model advancements, plus some policy and regulations and industry applications, etc. All of these are the latest news in the domain. And these are not just the one tool. You can even, we have already used one other tool called Create Image, or if you want to perform any deep research, you can even call the deep research tool. So over here, we are selecting the tools ourselves, but you do not need to even select the tool. If you give it a prompt, the model itself can decide what tool it needs to call in order to respond. So instead of asking the model to create an image, I can also just say, I want a visual depicting, you can say, I want a visual newsletter. I want to create a newsletter containing all the above information. Create, let's see, create an image for the same. So here I have asked it to summarize all the previous information in a newsletter format, and it needs to create an image that can contain. So here you can see it automatically has called the tool that will help it to create the image containing all the information that was shown above. So over here, I did not ask or I did not select the tool for me to create the image. Rather, the agentic AI at the backend, the agent that was called first, that agent decided to use the tool image, the imaging tool here, and gave the prompt to create an image that can summarize all the latest information that has been provided at the top. So let's see how the output will look like. So as you can see, it has started to generate some responses, and it is also telling us the date at which this particular response has been generated. It started off with the major model advancements. It has summarized all the latest news corresponding to the model advancements as well. So that's the first part which it is writing over here. Right? So whatever it was showing us at the top, it is now creating a newsletter that contains all the details in a nice graphical interface. Right? So that is basically the power of generative AI, wherein you ask the model to behave a certain way and you do not even have to worry about deciding which tool to use. The agent will decide which tool needs to be called, right? So here, if you go back into the details of how this particular tool would have worked, so there are two tools that would have been called, right? The first tool that we have called is basically going to do the latest research on the web. Now the web research is going to return you all the latest articles that can summarize the information about what's going on in the field of generative AI. Then these articles were fed to the large language model, and this large language model then summarized all the content for us. Right? After we had the summarized content, then another tool was called that can generate our image for this. Now this content was sent to the model generator, image generator model, and then a newsletter was created that basically summarized whatever was happening in the domain of generative AI as the latest available information. Right? So that's basically the entire flow chart of how the interactions have happened, and as a user I did not have to manually select any of these things. All the selections was done by the agent that is working on my behalf to call the right tool and give me the right responses. Right? So that's what this flowchart also says. You give a user prompt, agent will plan the action, call the tools, process the results, and it will respond back with the final answer. So in our case, the final answer is basically this particular newsletter that contains the latest releases in the domain of generative AI as per May 2025. Right? So we have seen this ChatGPT with tools, right? So we have seen how browsing works, how it can fetch the articles, and how it can summarize and reply us back in a single short example. Now there are other real world use cases for agentic AI as well. It's not just limited to a travel assistant or a chatbot kind of a phase, but you can integrate it in a lot more different domains. We have already seen the advancements that the customer support agents have made. So a lot of companies nowadays, instead of redirecting you directly to a manual assistant, a person, they first give you, ask you to interact with an AI assistant in between. You tell your query to the AI assistant, and then AI assistant will decide which team it needs to route to get the resolution for your problems. Right? So here you are just asked to call the problem, and the assistant will then take your responses, your audio that you have said, process it, and then decide which team it needs to route it to so that you can get the responses in the shortest available time. You can even create research assistants wherein you can ask the users to give whatever research you want to perform, and then based upon the user input, let's say you want to perform some research in the medical domain, then it will do the research on all the medical articles that are available, summarize it, and give you the responses. Right? You can even create travel planners like we have seen in our example as well, wherein we have defined a user assistant that can work as a travel guide, a travel advisor, and we can even ask it to integrate a lot more tools like asking us what the weather is at that particular place, what the cost of it would look like, if it can help us book the flights and things like that. So that's all that we had to cover in this particular module. In the coming module, we'll start talking about a very important Python package called LangChain that helps you develop these agentic AI frameworks with ease. That's all. I'll see you in the next video. In this module, we'll cover the basics of LangChain, which is one of the most popular Python framework meant for development of applications using large language models. So what exactly is LangChain? So it's a Python framework. It's completely open source, means that you do not have to purchase any subscriptions for using this particular framework. And it was majorly developed to overcome multiple challenges that are present within the development of large language model applications. So we'll cover first what are the benefits that you get when you develop applications using LangChain. Beginning with the first benefit is basically LangChain gives you a centralized place to manage all of your user prompts. We'll see this in action as well on how you can easily manage prompts using LangChain. So it gives you a structured interface using which you can very easily manage what all prompts are required for your various tasks that you want to create. Second, you can use LangChain to chain multiple steps together. So in fact, the name LangChain, the second keyword of that particular name contains the word chain. So using this particular framework, you can very easily chain different steps together. You can create a flowchart wherein you can decide what next steps needs to be taken in order to get to the final response. The third benefit is of memories. So with LangChain, memory management and context-aware model generations can become very much easier. So you do not have to manually, keep a track of all the previous responses that have been generated. And the fourth benefit of LangChain is of tools integration. Now, in the last class, we have already taken a look at what are the benefits of tools. Tools allow you to perform web searches, create images, and do much more things. So with LangChain, you can develop or define your own tools and integrate it within your entire LLM framework very easily. We'll cover all of these topics as we go forward. So let's take an example to understand the usage of LangChain better. Imagine you want to develop a chatbot for handling orders in a coffee shop. So in this particular scenario, what would you require? You would require an agent that can first remember who the customer is. So imagine that you are developing this chatbot for a coffee shop. The chatbot starts the conversation by asking the customer their name. The customer is going to reply their name saying that, okay, I am Josefa. And then the chatbot can come back and ask me what should I order for that particular coffee shop, right? So whatever order I am going to place, the agent needs to remember those orders. So it will take all of the orders that I am placing, and then depending upon my order, it can start to follow up, right? So it can tell me what other compliments can I add or got together with my order, how much time will it take for the order to get delivered, what would be the final bill amount, and things like that. So in this particular scenario, there is a chain of events that are happening, starting from the conversation wherein the agent is asking me my name, followed by taking my orders, next placing my orders, and whatever other queries I have related to the order pricing or the wait time, etc. All of those queries needs to be addressed naturally. So for such an application to be developed, you can very easily use LangChain to define these chains, define the different tool integrations that will allow you to place orders, respond to the user queries, and so on. So to get started, the first thing that we need to do is install our dependencies for LangChain. So the dependencies that we'll require for this session are three. The first one is the package LangChain itself. The second one is OpenAI, and the third one is Python's .env package manager. Now, OpenAI has already been installed in our previous session as well, so it's not mandatory to install it again. What you need is basically installation of LangChain for this particular tutorial. And in order to install it, all you need to do is run the basic command pip install LangChain. Right? So this is the first package that you have to install, which is the LangChain. And the second one, which will also be required, is LangChain OpenAI. Now I'll cover what LangChain OpenAI is in just a minute. Before diving into the details, let's quickly jump onto the official documentation of LangChain to understand the entire ecosystem much better. So here I am showing you the entire ecosystem around LangChain. So LangChain has different parts. The first one is the package LangChain itself, which is completely open source. This particular framework allows you to define the core components of LangChain, which includes messages, prompts, tools, etc. So all of these are part of the LangChain's core tool development. Then you have third-party integrations. So generally, when you develop any large language model application, the biggest challenge that you would face is that there are hundreds of LLM providers out there. You could use the large language models provided by OpenAI. you could use the ones provided by Google, you could use the ones provided by Anthropic. And each one of these APIs has a different usage curve, right? So it's not like how you interact with OpenAI, like we did in the last class, like we did in the previous session. It's going to be the same of interaction with Anthropic or Google's APIs as well. The interactions will remain different. So LangChain, first of all, what it does, it standardizes the usage of different tools as per your requirement. So if you take a look at all the integrations that are available out there, you will see that LangChain supports integrations across this entire list of packages, right? So you can take this package name. So let's say you want to work with LangChain using Google's Vertex AI packages. So you can just install the package called LangChain's Vertex AI, and this will give you support to work within the LangChain's ecosystem and integrate the models provided by Vertex AI. Similarly, if you want to work with Anthropic models, you need to install the package for LangChain Anthropic so that you can use the Anthropic models within the LangChain's ecosystem that you are working for. In our case, we'll be using OpenAI models. So therefore, we are going to install LangChain OpenAI, right? So this is the model that we will be installing, right? So when you install packages called LangChain underscore package name or the model name that you want to work with, so you will get access to all the large language models provided by that particular framework. So let's get back. So apart from the integration, you have other tools that gives you much more advanced capabilities. So one such tool is LangGraph. So LangGraph is basically a tool that gives you ability to define or to create a graphical interface wherein you can define the different multi-agent workflows. So let's show you a quick example of how this multi-agent workflow would look like. So on this page, this is basically a example shown by LangChain itself, wherein depending upon the interaction, so here we are starting the interaction, then the message goes to an assistant. Then if the assistant thinks that it requires to perform a web search, then a corresponding tool for performing the web search will going to be called, whose response will go back to the assistant. This response will again be, reformatted, right? So it will enter the right sequence, and depending upon that, it will redirect it to the writing assistant, right? So what it does is basically defines a workflow wherein multiple agents are used, and you can define such complex workflows using LangGraph as well. So LangGraph is also open source, and it's part of LangChain's ecosystem that gives you the ability to define multi-agent workflows very easily within LangChain. So these are the different tools available, and the third one, which is also very, very useful, is LangSmith. So LangSmith gives you the ability to deploy these frameworks that you have developed. So whatever large language model application you have developed, you can very easily deploy it. And once you have deployed, after deployment, there are multiple things that you need to perform in order to make sure that the application is running smoothly and without any errors. So this includes abilities for debugging, testing, annotation, monitoring, etc. So all these abilities are part of LangSmith's capabilities. So this software is basically also, so although integrations, LangChain Core and LangChain Graph, so you see here these three applications are open source. So wherever you see OSS written, it stands for open source services. So these are completely open source softwares. So since these are open source, you do not need to pay any licensing fees for them. But you need to pay a licensing fee if you want to use LangSmith or LangGraph platform. So LangGraph platform is basically a UI based application which allows you to easily work with LangGraph, right? So LangGraph platform and LangSmith are commercial, meaning they require a licensing fee to be paid, but the integrations, core components and LangGraph remain open source softwares. That's why you have OSS written against them. That's a quick brief overview of the ecosystem around LangChain. So in order to get started with today's demonstration, as we did in the previous session, here also we need to first set up our .env file. In this .env file, we need to create the OpenAI API key, because in this particular demonstration, we are using the same model from OpenAI. So the steps for creating OpenAI API key remain the same. You need to go to the platform for OpenAI, log into the website, create your account if you do not have it already. Create your API key and paste it inside a .env file. If you do not remember, or if you do not know how to follow along or create this .env file, you can check out our previous video wherein we have shown you step-by-step process of creating this .env file. So let me show you what this .env file looks like in my system. So here I have this .env file. This .env file will contain my OpenAI API key, and this is basically the API key that I have pasted here. Now, as I iterated in the last class, these API keys are meant to be kept as secrets. It's not meant to be shared. You cannot use this API key because I would have deleted it by the time this video is released. So you will have to create your own API key and place it in this particular file. Okay. Once this API key is ready, we are set up and we are ready to work with LangChain and OpenAI together. Okay. So first let's understand the different core components that are present within the LangChain core packages. The first one is the prompt template. Prompt template is a functionality within LangChain that allows you to create prompt templates. Let's understand how this particular entity works. So I'll jump into my notebook and we'll basically start with this prompt template functionality first. So in order to get started, the first thing we need to do is essentially import the packages. So here we'll say from LangChain core. So first, before starting, we need to load our .env file so that our environment variables are loaded. So first thing that we are going to do is we are going to load our environment variables. In order to do so, we are going to quickly load. So we'll say from .env load import load.env, right? And here we are going to run the function which will load the env file for us, and we are going to get our API key out from here. So let's quickly get the API key here, right? So what this API key is doing, this variable will contain the API key that I have created inside my .env file. So once we have our API key set, we can then later on use the models which are going to help us generate our responses. So now I'm going to import the model from LangChain OpenAI. I'm going to import my chat OpenAI model. So this chat OpenAI model is the wrapper around the OpenAI implementation itself that allows you to standardize how these models are invoked and how you get the responses back from the models, right? So I'll basically import the chat OpenAI model as well. Next up, we are going to define an object of our large language model, right? So here what I will do, I will use the chat OpenAI class that I have imported here to define an object here. So here I'll say the model is going to be, so in this particular case, what I'm doing right now is I'm calling the chat OpenAI, I'm calling the chat OpenAI class. I'm defining which model I want to use here. So in this particular case, I want to call the model GPT-4o mini, and finally provide the API key that we have initiated above. And secondly, we are going to then invoke this particular model. So the first standardization that has been done is basically each of these runnables that I'll show you, they have an invoke method. Using the invoke method, you will basically call the underlying large language model, and the large language model will expect a certain instruction. So in this particular case, we are invoking our large language model and providing it an instruction to tell me what is the capital of France. So in this particular case, I am giving a straightforward instruction and asking the model to tell me what exactly is the capital of France. So as you can see, the output from this particular model is essentially the content which tells me what the capital of France is. So in this case, the capital of France is Paris, right? And I can get these individual entities out as well. So I can say print response.content. Instead of printing everything, I'm just going to print the content from the response, right? So you can see here the capital of France right now is Paris. But let's say I do not just want the capital of France. I also want to know, let's say, capital of England or capital of Australia. So every time I want to run this particular, this instruction, I will have to go back and keep on changing this particular country that I'm calling it for, right? So for this particular example, let's say if I again want to know what's the capital of Australia. So capital of Australia, in this case, if I run this particular invoke function again, it's going to call, but this time I had to manually give it a new prompt, right? I had to create a new prompt myself, right? I did not have the ability to automatically generate the prompt based upon my usage. Here I had to manually set a new prompt. So in this case, I'll have to again run the invoke function and again print what the content looks like. Right, so you can see here in this particular case, the capital of Australia here is Canberra. So Canberra is the capital of Australia. But using the functionality of prompt template, you can make your life much more easier because it gives you the ability to templatize what exactly you need to query the model. Let me give you a quick demonstration of prompt templates now. So here I'll say from LangChain chat prompt template. Right? So in this particular example, now what I will do is I'll first import my chat prompt template. After importing the chat prompt template, I'll first create a prompt template. So in this particular case, what I have done is I have called the object of the class chat prompt template, and then I have called a generator which allows me to generate a prompt template based upon this particular query. So here you can see I have kept the instruction same. I'm saying what is the capital of, but instead of providing the country name, I have templatized it using a variable. So what is going to happen in this case is that I can now use this template to create the prompts for different countries of my choice. So here in this particular example, if I just run this particular function, so what's going to happen now is I have a prompt template available with me, and right. So in this particular case, I can say prompt dot invoke, and when I run the invoke function on top of this particular prompt, so what will happen now is it will return me a new string which contains my prompt value, and this time you will see the output will contain what is the capital of France, because in this case I have asked the model, in this particular case I have asked this template to replace the country variable with the value of France. So I can use the same template, I can define a template, define the variables within the template, and when I'm using the prompt at the time of invocation, I can pass these attributes as per my understanding. So if I want to know the capital of France, I'll set the country variable to France, and now when it's returning me the value, it will replace country with France. If I want it for some other country, if I want it for India now, so now all I have to do is basically run it again, and this time I will get the response. Just in this particular case, it will be for India. Okay, so in this particular example, you saw how you can use the template, how you can create templates and use it for different variables within the same template. The second core component of LangChain are LLM chains themselves. We'll create some chains today in this demo as well in a later part of this video, wherein we'll show you how easy it is to define chains using LangChain's framework. The third is its integrations with other third-party vendors. Now I have already shown you that how easily you can use LangChain with Anthropic, OpenAI, Google's own Vector AI, right, Vertex AI, and so on. Plus the fourth and the fifth biggest advantage is its memory integrations. So using LangChain, it is very easy to manage the memory, which allows you to keep a track of the previous conversations that have happened between yourself and the backend large language models as well. So now we'll go back and see what other prompt templates can be created using the LangChain's prompt template features. So over here we have created a very simple prompt template in which there was just one single instruction, wherein we are asking the model as a user what exactly is the capital of a given country. We have templatized it by providing a country attribute which is set at the invoke time or at the runtime. But in the last session, I have shown you within OpenAI how you can assign different roles to a particular conversation. So if you want, you can even set a role at a user level or at a system level or as an assistant level. So the same structure is continued within LangChain itself. So LangChain also provides you access to different types of messages, and you can use those messages to store responses based upon where those messages have come from. So if a message is such that, let's say you are interacting with a large language model and the model gives you a response. So in this particular example, if you see, we are getting the invoke function and we are printing what the result of the invoke function is giving back to us. So if you see the output contains multiple messages. The first message is the human message. So this human message is basically the instruction that you gave to the model, right? So here we ask the model what is the capital of India. That's a human message. That is a user asking the large language model what is the capital of India. right? In response to this, we can then later on send this particular human message to an LLM, and the LLM will then return us back the value for that particular response. So let me show you how that will look like. So I can say LLM dot invoke. So in this particular case, I am calling the LLM now, and this LLM is getting passed the prompt that we have generated above. So whatever prompt I have created, which is basically a human message, this human message is now passed to the large language model, saying that now I want to know what the capital of India is. So let's store this response in a variable again and run it. And let's print this response. So you will now see the response is an object of AI message class. So AI messages are basically the messages that are returned back to us from the AI assistant, right? So within LangChain's ecosystem, the assistant messages are basically stored as an AI message. So that's basically the response that you are getting from the large language model itself. So you can see here the content of this particular response is essentially saying the capital of India is New Delhi, right? So if you print the content here, the content here will basically be the response that is generated by the large language model itself. And you can even create much more complicated prompts here. So let's define a more sophisticated prompt which contains two roles. One is a user role and second one is, let's say, a system level role. As we did in the last video, wherein we assign a user level as well as a system level role to the model's prompts, here also we'll do something similar using chat prompt template within LangChain. So first, let's start by defining a system prompt template. So here we'll say translate. So here we are defining an interface that easily allows us to translate text from English to any foreign language. So here what I have done, I am asking the model to translate whatever text is following from English to any other language. This is a template that I am currently creating. After that, we'll define a prompt template using chat prompt template class itself. But this time we are going to use the interface from messages. So what this interface allows you to do, this interface allows you to define multiple messages one after the other. This messages is similar to how we define messages using OpenAI package also. So in this particular interaction, what we will do is we'll define multiple messages one after the other. So first message we are defining is the system level message. The system level message is going to come from the prompt template which we have defined above. So here we'll say at the system level message, we are going to ask the model to translate whatever text is following from English to any foreign language. And then from the user's point of view, the user message is going to be the text that will be followed by this template. So in this case, we are having two placeholders. The one placeholder is the language in which we want the translation to happen, and the second placeholder is the text that is supposed to be translated, right? So here we are defining two placeholders, one to contain which language we want to translate in, and the second is the text that we want to translate here. So at the time of invocation, when I'm calling the large language model itself, so here you will see we are calling first the prompt template and asking it to invoke, and here the text that I am passing is I love programming in Python. Let's say here the text that I am passing is I love programming in Python, and the language that I want it to be translated in is Hindi. So here you can see I am passing the values for these two variables at the time of invocation at runtime. So at runtime I can customize what values I am passing to the model. So language is Hindi and the text that I am calling is I love programming in Python. And then we'll basically call this model and get the response back from the large language model. Let's quickly print the response here. So here you can see this is what the response or the conversation in Hindi would look like for this exact text. And that's not it. If I want, I can do this same translation for other languages as well. So I can call the same structure, but this time I will say let's do it for some other language. So instead of Hindi, let's do it in French. And here again, if I print response.content, you will see this is what the translation looks like for French. So you can see how easy it is to customize how the interaction is going to happen using prompt templates from LangChain. Without the prompt templates, you have to do you have to call the same prompt again and again with different user inputs. But with the templates, you can define variables and then pass the values to those variables at runtime, right? And here you can see the large language model is going to be invoked after the templates have set the respective value for text and the language that we want to call, and the response will contain the returned response from the large language model directly. Okay, that's basically a quick demonstration of how the prompt templates work within LangChain ecosystem. So before proceeding, let's quickly check what's the object for the response class that we have gotten now. So if you print the response right here, you will see that the response that you are getting, this response is an object of the class AI message, right? So when we sent our user query, that was basically a human message. So initially when we called this particular model, we are calling the model and we are passing a message as a human being. So that particular value is wrapped in an object of the class human message, because that message is going to the model for generating the answers, and the response that we get from the model, those are wrapped in the object of the class AI messages. And this AI message will contain the content from the message, plus it will also contain some other additional information about how much tokens have been used, right? How many tokens were completion tokens, that means how many tokens were in the final prompt, the response that the model is returning, how many tokens were there in the input prompt, and total how many tokens have been consumed, right? So all of these information plus some details about the cost and all of those additional information will also be there. So it will also contain the model name that was used and etc, right? So all the information that might be relevant from the response perspective of the model is also contained within the object of the class AI message. So if you wish, you can just use these individual attributes from the response object to get the information around the number of tokens consumed from the prompt, number of tokens consumed from the chat, etc. Okay. So right now we haven't defined any chain, but if you wish, you can either call these attributes in this fashion, wherein you call the invoke function one after the other, or if you wish, you can even make it more simplified by calling it in the format of how chains can be defined. So here, next up, I'll show you a quick demonstration of how you can customize or how you can invoke chains one after the other. So let's define a simple chain here. So here I am going to define a chain by saying that it's going to contain two things. The first is the prompt template. The prompt template here we have defined that contains the system and the user level inputs that we need to give, and the output from the prompt template will go as an input to my large language model, and whatever the large language model will return, that value will be basically the final response that I am generating as an output from the model. So here we have defined our chain. So this is basically a simple demonstration of what a chain would look like. So once we have defined a chain, I can call this chain and I can say chain.invoke. And in this invoke function, I can then pass the attributes that I need to set for this particular chain to function correctly. So I will say when I'm invoking this chain, I will call the text. So I will pass the attributes for text, which will be I love programming in Python. And I will say which language I want this translation to happen in. In this case, we want it to be translated in French. So here, when I invoke this chain, I will again get back my response. When I run it, let's print the response again. You can see here, it has basically started from the prompt template. It has passed the text and the language attribute in the prompt template, set the prompt template correct, and then pass the output from the prompt as an input to the large language model. And then finally, we have the response back from the large language model. So chain allows you to chain these different entities one after the other depending upon your requirement. So whatever the output will be, those output will be sent to the second model or the third model and so on. So you can chain these different inputs one after the other to get the final response back. And this is fairly easy. So there are two ways of doing it. Either you create chains in this fashion, you define your chain and invoke the chain directly, or you can manually invoke individual entity by nesting it within itself. So the first inner nesting will be of the prompt template, wherein you invoke the template first, pass the attributes, and the output for the prompt template will be passed to the large language model to get the response. Or you can define your chain that structures how these entities should be called one after the other, and then you just invoke the chain only, set the attributes for invocation, and you will generate the response in a single shot. So that's the benefit of defining chains. So they allow you to streamline how these individual entities are going to club together with each other. So in the next demonstration, we are going to look at how the concept of memory has been integrated within the LangChain ecosystem. We'll first begin by importing the necessary objects that will allow us to create or track the history of messages that has happened between us and the large language model itself. So first let's define the placeholder for message. First let's import the required placeholders first. So I'll say from langchain.core prompts, right? So first what I will do is I'll import the class called messages placeholder. This placeholder will store all the messages or the interactions that have happened between us and the language model itself. We'll define a variable called messages. Inside this variable, we'll store all the messages that have been forwarded between us and the model. And finally, we'll define our placeholder. We'll say this particular placeholder to be a messages placeholder. And this messages placeholder will store this variable called messages to keep a track of all the interactions that have happened between us and the LLM itself. Next up, we need to define a prompt template to contain these placeholders as well. So right now we have just defined a placeholder that is going to contain all of my messages. So we'll pass this placeholder then to the LLM itself. So when we invoke the template of the prompt, there this placeholder will basically be replaced by the actual history of messages that has happened between the model and us. So here we are now going to define our prompt template. And in this prompt template, the first part that we will pass here is basically the placeholder, right? So in this particular example, you can see that the first thing that I am passing is the placeholder itself. This placeholder will contain the messages here. And the second thing is essentially the user input that we are going to pass next. So this input is going to come from the model itself, from the user itself, and the user will pass whatever input I want the model to return, right? So here there's some interaction that has happened, and here we'll say, I'll delete this bit. And in this particular prompt template, we are defining the placeholder, and we have defined another variable that is going to contain the input that is supposed to be coming from the user. This is just basically the template that we have defined. So here in this particular template, we have the placeholder that contains the previous history and the next input that is supposed to come from the user in order to continue our conversation. So our prompt template is ready. Now we are ready for defining the chat loop. So in this chat loop, we are going to keep it very simple. We will continue the conversation until the user wants to stop the interactions. So we have already defined some placeholders to contain the previous chat history and the next input for the user. So let's begin by first defining what the user input is. So here I'll call a variable called user input, wherein I'll take the input from a user. So I'll say enter your message, right? So here the user has defined the message that they want to call. So whatever the message the user will pass, I will take that message and store it in this variable called user input. Second, I will define my chain as I did previously, wherein I'll first call my prompt template, right? I will first call this prompt template here. So I'll first call my prompt template followed by a call to invoke my large language model. And then we'll define a simple loop. So we'll say while the user input is not equal to exit. So until the user has requested to end the conversation, I'll continue to run my loop. And what I will do first is I'll basically first append whatever previous message I have received as an input from the user. So I'll say messages.append, and I will append my message as a human message. So whatever input I have received from the model, that input that I have received will be appended as a human message. So I also need to import it. Let's quickly import the human message as well. So from LangChain core.messages, we need to import the human message as well. So this class is basically used when you want to define a message as a human message or the message that is coming from a user. So I'm going to append my message as a human message, and the content is basically the user input that I have provided here. So now once this message has been appended, then I want to generate the response from the large language model. So I'll say chain.invoke, and the chain that I'm invoking right now, I need to invoke this chain, and I will say that input that I have, input equals to my user input. Okay, so in this particular case, I will get some response back from the model. Let's quickly print the response as well. And once we have received the response back from the user, let's append that response as well inside my messages history. And once this message has been appended, then I am ready to accept another input from the user. That's it. So here what we have done is we have defined an interface that basically continues our chat until the user has requested to exit from the loop. So until the user said that, okay, I am ending my conversation, I will take whatever input the user has given, append that input as a human message first, then I will invoke my large language model, get the response back from the model. That will be an AI message. That will be the response generated by the assistant that we have. I will append that message next in my chat history, and then I will go back to the user and asking the user what your next input is going to look like. Right? We can even add a condition saying that so over here itself we can even set that if the user input exit, we can basically print exiting the chat, and we can then immediately break out of the loop as well. Right? So in this particular case, we are going to check if the user input is exit, then we are also going to print a text which says that, okay, we are done with the chat, we are now exiting our chat. So now we are going to see how this particular chain works in action. So we'll see how the memory is updated and see how the responses are changing as we keep on calling the model again and again. Let's execute this. And you can see at the top it's asking me for my user input. So let's begin by saying hi. Okay, I've received an error. Let's quickly see what the error says. Mapping type is supposed to be, okay, it's supposed to be mapping. Actually, we have provided it as individual inputs. This has to be corrected. Just give me a second. So here this is going to be wrapped in text. This is also wrapped in text, and this is correct. So basically when you invoke any particular chain, these attributes have to be passed as the variable names that you have set above, and then these variables will be replaced by whatever inputs you are passing here. Okay, so we have already defined our messages placeholder. We'll pass those messages as an input here, right? And then whatever user input the user has provided, that will go again as a second placeholder here. We'll basically print what the response is generated from the model, and we'll append that response as well in the same message history that we have created. And then we'll ask the user for the next input that they want to share. Okay, let's execute this. And now let's also begin by saying hi. So you can see here when we said hi, the model has responded saying, hello, how can I assist you today? And then you can again enter your next message. So let's say I want to travel, I want to plan a travel itinerary. So here we have sent a second message to the model. Let's see how the model responds. So here the model has responded again saying that sounds great. To help you plan your itinerary, the model needs some information like destination, duration, interest, travel dates, and so on. So you can then again respond to the model saying that I want to travel to, let's say, Japan. The travel dates are next week. And I want to plan for 10 days. Right, so here we have basically said to the model that this is what my destination is, that's the duration and everything else. Let's see what the model responds back with an itinerary that it thinks is appropriate for that particular duration. So as you can see, according to the information that we have provided, this is what the itinerary that the model thinks is suitable for us. If we are happy with it, we can just type in exit, and now this particular conversation is going to end, and you can see we are exiting the chat. So with the LangChain, you can very easily manage the previous messages history. All you need to do is basically use the placeholder for storing all of your previous messages. So you need to define your placeholders correctly, right? So this messages placeholder has to be created that contains all of your previous conversations that have happened with model and yourself, and pass these messages placeholder as an input at the time of calling the model itself, right? So when you are invoking the model, time of invoking, you will pass the placeholder and you will call the placeholder and you will pass it as an input, as a first input to the model as well, right? So here, that is how you essentially define and you use the messages that have happened in the past along with the next input that you want to give to the model, and we have created an end-to-end chatbot that is allowing us to interact with our end user as well. So that's it for this particular session. In the next video, we'll discuss about the vector databases and vector scores. So I'll see you in the next lecture. So in this session, we are going to be discussing the concept of vector embeddings and vector stores. These concepts are going to be the building blocks for the further sessions on retrieval augmented generation or RAGs. In this session, we are going to understand how we can convert text into machine understandable format known as numbers, right? So machines cannot understand text. They require numbers to perform the operations. So here we'll break down how we can convert text into numbers and store them inside vector stores. To begin with, we know that machines work on numbers. They work on binary values 0 and 1. So how do you convert these text into numbers? The answer to this lies in the concept of embeddings. So in order to understand these words, take a simple two-dimensional graph for example. So on this graph, what embeddings do? The embeddings convert these text into numbers such that text with similar meanings are placed closer to each other. So let's begin by talking about what are embeddings. Embeddings are vector representation of text on a n-dimensional plane. So let's break it down and understand this concept with a simple two-dimensional graph. So consider this two-dimensional axis. Here we have x and y axis. And what embeddings essentially do, they take a piece of text and represent the meaning of those texts into a vector. So here we have two-dimensional plane. So let's take a few sentences for example. So first sentence is, let's say, I love pizza. Right? That is the first sentence. Let's say, and the second sentence is, I want to have a pizza. So what the vectors will do, so embeddings are going to convert this piece of text into a two-dimensional vector, right? These two-dimensional vectors will be such that when you plot it, they are going to be closer to each other because they are conveying a similar meaning. In both the sentences, we are actually talking about pizzas and we are expressing the way that we want to have pizza. So what the embeddings will do, these embeddings are going to be looking like a set of vectors for x and y coordinates. So let's take for example here, the x coordinate comes out to be 0.99 and the y coordinate comes out to be 1.2. For the second sentence, the x coordinate comes out to be 0.81 and the y coordinate comes out to be 1.5. How these embeddings are generated, that's not the agenda for this session, but the idea here is to take a piece of text and convert it into its vector representation. So when you plot it, what you will find is that these two vectors of sentence 1 and the vectors of sentence 2, the vectors of sentence 1 and sentence 2 are going to be very much closer to each other. On the contrary, let's say we have a third sentence which says, I want to learn machine learning. So this sentence is conceptually very different from the previous two sentences. So the corresponding embedding of this particular word will be farther away from these two words. Or the conceptual embedding of the third sentence, which is I want to learn machine learning, will be farther away from the meaning of the first two sentences. Right? So remember, the first two sentences were talking about the affection towards pizza, whereas the third sentence is talking about the need for learning machine learning. So here these two sentences are conveying one set of meaning, whereas the third sentence is conveying a totally different set of meaning. So therefore, on the embedding dimensionality plane, there the embedding of this third sentence will be farther away from the embeddings of the first two sentences. Right? So therefore, words with similar text will have similar vectors, or their vectors will be much more closer to each other. Now you might be wondering, why do we need to create embeddings in such a way in the first place? The reason being that when you have created the embeddings, so imagine that next up what we will do is we will take those embeddings and we will store them inside a vector store. So a vector store is nothing but a database that can contain all of your embeddings. So consider this table right now as a demonstration of these vector stores. So within this vector store, what will happen? It will basically contain all the text that you have provided. So here we'll have text and their corresponding embeddings. Right? So we had the first text about love for pizza and the embedding for the first text, where the second text about you want to eat a pizza and the embedding for that, where the third sentence about I want to learn machine learning and the corresponding embedding for that. So once you have stored all these embeddings inside a vector store, Now let's say a third person comes up and they want to retrieve all the similar pieces of text towards a certain query. So what they want to do is, let's say they have a third sentence, right? How about a pizza? Right, so let's say this is a new query that they have given, and what they want to do is they want to retrieve all the text that are similar to this particular sentence from your vector store. So what you can do is you can similarly convert this new query into its own vector, right? So whatever the new vector will be, and I will take this new vector and run a similarity search to retrieve all the similar vectors from our vector store. So the vectors that we have created, they allow us to calculate similarity. With similarity, we will understand which vectors are closer and which vectors are farther away from each other. And once the similarity search is done, the end result, we will basically get the list of vectors which are most similar to each other, or in other words, we will get the sentences or the text from the original vector store which are similar to the original query which we have provided. Now this concept is the building block of retrieval augmented generation. How it is used in RAG, that we will cover in the next module. So let's see this in action and understand how to convert text, chunk it, store it and retrieve it. So now let's get started with the hands-on. In this, we'll practice how we can actually create our embeddings, store them and retrieve based upon a certain user query. So let's begin by importing our dependencies first. So we'll first import our OS module. Next up, we are going to import our document loader. So here we'll say from LangChain underscore community dot text load dot loaders. So we'll say from LangChain community dot document loaders, we'll import our text loader. Next up, we are going to import our splitters as well. I'll explain the concept of splitters in just a second. So here we'll say from LangChain underscore text splitters, import recursive character splitter. We'll also import our LangChain dot hugging face, when we'll import our hugging face embedding. Finally, we'll import our vector store as well. So I'll say from LangChain community dot vector stores, import FAISS. Sorry, there's a text spelling mistake. Yeah. So let me explain what each one of these classes are going to help us do. So first of all, the text loader class that we have loaded will allow us to load the document that we want to embed in our vector store, right? So the document for which we want to create embeddings, that document has to be loaded within our Python environment first, and then we'll be able to store it within the database. So here we are going to load the document which is in text format, right? So it's a simple text file. So therefore, I have imported my text loader. Depending upon your requirement, you have other loaders as well. So if you want to load documents from HTML files, from PDF files, etc., then you can use the corresponding loader function or the loader class to load that document into your vector database. So for our demonstration, we are using a text file. That's why we have imported the class called text loader. After that, you can see we need to split our document into text. This particular next function, which is recursive character text splitter, this will allow me to split my document into chunks. So a lot of times what can happen is that a document that you are trying to embed can be too huge to be created into a single vector, right? The size of that document can become too big to handle in one shot. So therefore, using the splitter functions, we can actually split our document into sub-documents, smaller chunks, right? And then use individual chunks to embed it into our vector store. I'll demonstrate this functionality in detail in a minute. The fourth one is our Hugging Face embedding class. So this class allows us to embed a chunk of text into its corresponding vector representation. We are using Hugging Face embedding because OpenAI embeddings require us to pay a subscription. So for the purpose of the demonstration, we are using classes that are free for anybody to use. So therefore, Hugging Face embeddings are open source. You can use them easily for any machine. And finally, the vector store that we are going to use for storing our embedding is FAISS, which is a vector store created by Facebook that allows you to store and retrieve files in a much faster way, right? So FAISS stands for Facebook AI Similarity Search, which is a document vector store that allows you to retrieve the documents fairly easily. So let's begin by loading our document first. So we'll define a loader here, which is basically a text loader that is going to load the document file that is stored in my system. Let me show you what document we are trying to embed. So this document is a simple document that contains a company's policy. Here we are writing a piece of text that says that all employees are entitled to 20 days of paid vacation annually. The work hours are from 9 a.m. to 6 p.m. Remote work is allowed for 2 days a week, and the health insurance is provided to all the full-time staff. Right? So we have created a simple text document that contains a few of the company policies. And the idea here is to basically embed the text present inside our document. And then let's say a user comes in and the user wants to answer a few questions depending upon, let's say, they say, how many paid vacations do I have? And our goal here would be to take that query and search which is the best suited text from our database that can answer the question that the user has posted. So we'll take this document and embed it inside our vector store here. So you can see here the first thing that we need to do is first we need to load our document. So therefore you will see here that I am creating my text loader class, and then finally I load the documents by calling my load function. So here next up, after my loader has been created, I am calling the load function to load all the document that is, or to load all the text which is present inside my document. So if I print the docs here, you will see this particular document will mention the source, and it will also mention the content that is part of this particular document, right? So this is essentially all the content that we want to embed inside our vector stores. After that, we want to create our splitter. So in this particular case, now what we will do is we will take this document and break it down into smaller chunks. Now there are two reasons for doing it. The first reason is so that sometimes if the document is extremely big, now we can break it down into smaller manageable chunks and then embed each chunk separately. And the second reason is that since this document is containing text, right, so there is a lot of text inside this document and we want to pinpoint the exact answer. So what we will do is we'll break it down into smaller chunks with some overlap so that the model can effectively search and retrieve the chunk with the highest overlap, right? So here we will, let's say first piece of text could be all employees are entitled to 20 days. The second text could be employees are entitled to 20 days of paid vacation, and so on and so forth. So we are going to break it down into smaller chunks which has some overlap with the previous one so that we have enough pieces of sentences from our document, and then we'll store each sentence individually inside our vector store. So over here what I'm doing is, over here I'm basically taking my documents, right, and I'm passing this document to another class which is my recursive text character splitter. So what will happen, this particular splitter will allow me to split my document into chunk size of 50 characters. So each text will have 50 characters and there will be an overlap of 30 characters. So what does this mean? It basically means that, let's imagine that you have a piece of text, right, so which contains some n number of characters, and let's imagine that we are creating a chunk size of 5 characters. So what it will do, the first character which will, or the first chunk which it will retrieve will contain the first 5 character, and if there is some overlap, then what it will do, imagine that there is an overlap of 3 characters, then it will basically take the previous 3 characters of the last chunk and count the next 5 characters from there. So this will basically be the next chunk. Then after that the next chunk will be this one, and the fourth chunk will be this one, and so on and so forth. So it will break down your original document into chunks of 5 characters each with an overlap of 3 characters. So that will basically create my chunks from my original source document. So over here I am defining a class that can essentially divide my source document into a chunk size of 50 with a chunk overlap of 30 characters. Now after that, all I have to do is basically create my chunks. So for creating this chunk, for creating these chunks, I can call the splitter class and I can split the documents very easily. So here these chunks will be created, and once these chunks are ready, now I am ready to embed these chunks using my Hugging Face embedding model. So following this, what we need to do next is we need to define our embedding model. So here what I am doing now is basically I am defining a model that can create embeddings for these individual chunks that we have defined. Remember, each chunk is a piece of text which has 50 characters and an overlap of 30 characters. We can increase or decrease it. We will do that, and I'll demonstrate how the results will vary when we are increasing or decreasing our chunks. So now what we are doing right now is we are defining our embedding model. Here you can use this model here because this is again completely open source. We are using this model from Hugging Face to convert our chunks into embeddings. So I'll define this embedding model right here. So after we have defined our embedding, the next thing that we need to do is we need to create our vector store to store these embeddings. So after that, the next thing that I'm going to do is I'm going to define my vector stores. And this vector store is basically going to take two things. The first is it is going to take my chunks that I want to embed, and the second input is going to be the embedding function that is going to allow it to embed each doc. So over here, the first parameter are my chunks that I have created, and the second parameter here are the embeddings that will allow it to embed these documents inside the vector store. So over here we have created our vector store that will easily embed these chunks and will apply this embedding to create the vector embeddings for each and every text inside our chunks. So now our vector store is ready. The second thing that we'll do is, let's say we'll define a query over here. So over here we have defined a simple query. This query is asking how many vacation days are given as per the company policy. So I'll create this query, and the second thing that we will do is now we will try to retrieve the answer for this query from the vector store that we have created. Okay, so what I want to do now is I want to query my database that I have defined here and get the most matching sentence from the chunks that we have created to get the closest answer to our query that we have created. So let's create a retriever. Right, so what we will do next is we'll define a retriever that can retrieve the answers for the query that we have posted. So over here I have defined my retriever that can take the answers from the vector DB based upon the similarity of the query that we have defined. And let's take the results out. So I'll create the object of the results class. I'll create a variable called result that can invoke the retriever and get the queries here. And once these queries are ready, I can then start printing those answers one by one. So what we are doing now is basically we are taking our retriever, invoking the retriever and getting the responses back from the vector store here. Remember, this retriever is created as from the vector store itself. So it knows which document it needs to perform the similarity search on. So once these invoke function runs, it is going to return me the top matching results for our vector here. And then we can iterate through each of the results that we have received and we can print the content of that document below. So what you will observe is that these are the top matching chunks out of all the available chunks that we have received. Right? The first one says days of paid vacation leave annually, work hours. The second is entitled to 20 days of paid vacation leave. Right? So you will see that whatever answers we are getting, those answers are similar to basically what input we have provided. Now remember, there is no AI involved here. It's purely statistical in nature. It is taking this input sentence, converting it into its corresponding vector representation, and taking that vector representation and matching or finding the most similar vector out of all the individual chunks that we have stored. And what it is returning the chunks which has the highest match with the input query that was provided. Right? And that is basically how you can easily create embeddings for your input documents, store them inside the vector store, and use the retriever to retrieve the most matching chunks out of all the available chunks inside the vector database. So in this particular session, we have successfully created a vector DB and we have used the retriever to retrieve the most matching documents from that database. In the next session, we will now use this concept to start with the concept of retrieval augmented generation or RAG. I'll see you in the next lecture. Thank you very much. Hi everyone, in this session we are going to discuss the concept of RAG, which is Retrieval Augmented Generation, and how you can use RAG to develop document-aware chatbots using LangChain and FAISS vector stores. So let's get started. So we'll first discuss the concept of RAG itself. RAG stands for Retrieval Augmented Generation. With the help of RAG, we are able to first retrieve all the relevant documents from a particular database like FAISS. Based on the user query, the vector store will retrieve all the important documents matching the user query, and then will take all those relevant documents, create a context and put it inside a prompt. And finally, the prompt will be fed to the large language models to generate a more grounded and accurate answer for the corresponding user query. So eventually, RAG allows us to combine the capabilities of a search engine with a large language model. Why do we need RAG in the first place for this? The reason being, LLMs on itself do not have access to your company's documents or any official documents that are not available in the open source development. Say for example, you are working for an e-commerce company, and an e-commerce company like Amazon can sell hundreds of different products. And each product can have different return or refund policies. If a customer has purchased a certain item and they wish to return it, they might have an interaction with a chatbot wherein they ask, what's the refund policy for my given item? Now, a chatbot might not have
access to a company's refund, because at the back end, it will call a large language model and feed the query that the user has given to generate a response. Now, if this LLM has been trained on any open source data, then eventually it will know only the facts about whatever is present in this open source data. It will not know any information about that specific company's policies. So there is no information available with the model to understand what the policy of that company are, and hence it will not give an accurate response for the query that we have provided it. So how do we overcome this problem? Here RAG will help you. Here RAG comes to our rescue. So RAG will let AI get all the facts from the relevant documents, and then it will look at those documents before generating the answer that we want to get. So without RAG, AI will make generic guesses, right? Its response will not be accurate, which can lead to bad customer experience as well. With the help of RAG, AI will use the real information which is pertained inside our data set and then use that information to generate the accurate answers. Right? So for example, if the customer is asking us what's the refund policy for the item, then the RAG will look at the refund policy for that specific item and then generate the response by looking at that policy only. That's basically the benefit of using RAG with large language models. Now talking about the vector store that is recommended, it is FAISS. FAISS is developed by Facebook, which stands for Facebook AI Similarity Search. Right, so that's the full form for FAISS. This tool has been developed by Facebook, and the reason for using this tool is, first of all, it has excellent capabilities of retrieving answers at a very small period of time. It searches across documents extremely fast. There is no dedicated server required to set up FAISS. You can install it and run it as you run any other software application in Python. Right? Just install the package, set up the document store like we did in the previous session, and you are good to go. Right? And it's fairly easy to demo and test and practice as well. So that's the major reasons why we are using FAISS for this particular demonstration as well. Talking about the end-to-end workflow of how this application would look like. So as a user or as a developer, you would first take all the company relevant documents and load and split them inside a vector database, right? So we'll take the documents that are relevant to that particular company's policies, take those documents, load them, split them, and finally embed them inside a vector DB. For embedding, we can use different embedding models. You can either use OpenAI models, or you can also use Hugging Face models as well. So any of the two models can be used. For our demonstration, we will be using Hugging Face for embedding these different documents. Finally, once these models or once these documents have been embedded, we are going to store them inside our vector store, which is going to be created using FAISS. And finally, once the document store is ready, we can use that to retrieve the relevant information or relevant documents based upon an input query and create a context and send it to our large language model for further processing. Let's implement this using Python really quickly. So here we are inside our Jupyter notebooks, and as always, we'll begin by importing the dependencies first. We'll use load.env function to load the environment variables. This includes our OpenAI API key. Chat OpenAI will allow us to instantiate our large language models. So this will allow us to interact with OpenAI and get the responses from the LLMs created by that company. Hugging Face embeddings is the model that is the class that we will use to use Hugging Face models for generating the embeddings for our documents. FAISS is our vector store inside which we will embed our documents. Chat prompt template and the messages placeholder will allow us to create a prompt template such that the large language model will know the context as well as the previous message history that has happened between the model and the end user. And finally, we'll use the text loader to load our document text and recursive character text splitter to split those into small chunks. We'll first start by loading our environment variables. Once our environment variables are loaded, we'll begin by importing our document. So first, let's take a look at what data we are going to ingest in our vector store. So here we have created a simple document that contains a refund policy for a company. It says that customers in this company can request a refund within 30 days of purchase, item must be unused, and finally they can even send an email to this particular email ID if they wish to have any additional support for their particular refunds. So here we are going to load this particular document using our text loader function. So here let's create a loader first. Right, so here inside this loader we are going to feed the file text data.txt, and then let's load the documents by calling the load function here. Let's print it and verify whether the document has been loaded correctly. So as you can see, the source is data.txt and the content of this page is what I have shown you on this particular on this screen over here. So once our document is ready, we can then split it into smaller chunks. So for splitting it, we can create a splitter. Right, so here we will create a recursive character text splitter. We'll reduce the chunk size to, let's say, 50 characters and an overlap of, let's say, 30 characters. So this splitter that we have created will allow us to split our documents into smaller chunks. Remember, it's not mandatory to create a splitter. Use this only when your document is too big to be ingested in one single shot. Okay, so right now for demonstration, we are using the splitter, but it is not mandatory that you need to split every single time you need to ingest. Right? So once our splitter has been created, we'll then create our chunks. So here we'll be able to create our chunks, and these chunks will be passed individually to our embedding model, and the embeddings for each chunk will be stored in our vector store. So next is to create a vector store itself. So here we are defining a vector store using FAISS, and here we'll use the from documents function to embed the documents, right? And at first we haven't created our embedding model yet, so first let's define our embedding model itself. So let's create an embeddings model. Right, and the embeddings which we will create will be created using Hugging Face embeddings, and the model is basically the sentence transformer model that contains all mini large language model. Right, so this is basically the model name that we'll use for embedding each document text. We'll create our vector store. It's going to take a couple of seconds for running. Right, so now our documents have been embedded inside our vector store. Next up, let's also create a retriever that will allow me to retrieve the documents based upon a user query. After this, what we need to do is we need to define a function that can take an input text and that can take the embeddings that we have created and then retrieve the documents based upon which is the most matching one. So here what we will do is we'll define a function. Let's call this function as getResponse. This function will take two things as an input. The first one is the input text, and the second parameter is, let's say, a chat history. So this input text is going to be the input given by the user, and chat history is going to be the history of the previous conversations that we have had with the language model. First thing that we are going to do is first we'll retrieve all the matching documents from our vector store corresponding to our input text that has been generated. So here let's first retrieve the matching documents. And here we'll use the retriever object that we have created above, and we'll get all the relevant documents corresponding to the input text that we have provided. Once we have these relevant documents, then we are ready to define our context. And context is nothing but a line by line, it's basically a string that contains all the relevant documents in each line, right? So imagine that we get 3 documents back. So what our context will contain? So this context is basically going to be in line 1, we'll have the text from the first document. In line 2, we'll have the text from the second, and line 3 will have the text from the third. So like this, we'll basically create a string that contains the text relevant from the retrieved documents. Okay, that is what our objective here is. So over here, we are going to create, or we are going to basically define this, and we'll use the join function to join a list of text that we are going to retrieve. So here we'll use the page content. So this will return me the content for that document, and we'll iterate through each of these documents inside our matching documents class that we have created above. So this matching documents will retrieve all the matching relevant documents, and we'll iterate through each one of them, and we'll append that respective page's content in a new line. So once our context is ready, then we are ready to define our prompt template. Or first let's define the prompt template outside. Let's create a chat prompt template here itself. So here we'll define a chat prompt template, and this template will be defined using the functionality for messages. And here the messages that we will append, the first message that we will create, let's create a system level message first. The system level message will basically contain the instruction that the large language model needs to follow. So here we'll say you are a helpful assistant that can answer the user questions based on the context given. Right? And we'll also say if you do not know the answer, just say I don't know. Right? So basically we are mentioning this particular template that first of all what you need to do is you need to look at the context below, and also we'll create a placeholder for providing our context as well. So here we'll mention the context here. Let's write it within the text bracket only. Okay. So in this particular case, the first thing that we have done is initiated a system prompt. This system will basically say that the assistant is going to answer the user's question by only looking at the context provided, right? And if the model does not know the answer, then they will just reply saying that I do not know. All right. And let's also define the context in another line. Let's put the context here. Okay. So here we have provided our context, and after the context we have mentioned the model that you do not know the answer, just reply that you do not know the answer. Followed by a placeholder for messages history as well. So next up what we are going to do is we are basically going to devise a messages placeholder. And this messages placeholder is going to contain all of our previous chat history. Right? So I think I have imported it above. So let's define an object of the class messages placeholder itself. Okay. So here we are going to define the object of the class messages placeholder, and here the variable that it will be storing is known as chat history. So we'll pass the chat history that we will retrieve in this step as an input to the messages placeholder. And lastly, we'll also give the user's input, right? So this is basically the question that the user has requested us for answer. And this is basically a prompt template that we will feed to our large language model as well. Okay, so this is basically the template that we are going to follow going forwards. And in order to make it a little bit more explicit, let's add a couple of lines here, and we'll mention the keyword context followed by the context that the model needs to look at. Right? So I'm just making it a little bit more structured here, saying that the first line will contain the instructions followed by a couple of additional lines, and then we'll write the context followed by that, and finally a last instruction that will tell the model to reply saying it doesn't know anything if the context is not enough. Alright, that is what the template will look like. So now our prompt is ready, and the second thing that we have to do is basically define our chain. So in this particular case, the first part will be to use the prompt template followed by the input to our large language model. So in this particular case, we need to use a large language model. So let's define this large language model just above. So for the large language model, we are going to use the chat OpenAI, and here we are going to use the model GPT-4o mini. Right, temperature is not required here. Let's remove temperature, and we'll set the API key here as the OpenAI API key that we have loaded already using our environment variables. So likewise, what we will do now is we have defined a chain that will take first the prompt template. We'll replace the prompt template with the respective keywords here. So context will be replaced by the context. We'll give the chat history, and finally we'll also provide the input that the user has given. Now let's go back to our get response function and complete this out. So as you can see, we have first retrieved the context. Now all we need to do is basically we need to get the response back from the model by saying chain.invoke. And in this particular case, what we are going to do, we are going to replace each placeholder with the correct value. So input will come from the input text, context has already been created above, and chat history is also an input to this function. And what this function is going to return, this function is going to return the response that is generated from the large language model. So now let's test it out by using a simple prompt. So let's basically call this function once and let's ask it a simple question. So what is the refund policy for your company? So right now the chat history is empty because we haven't had any conversations yet. So we'll basically give a blank chat history for now. And let's see what the response is generated by our model. Right. So as you can see, the message that we have received is an AI message and it clearly says that the customers here can request a refund within 30 days of purchase. Right. So this particular query is giving us the right answer because looking at our policy as well, you can see clearly that it is written that customers can request a refund within 30 days of purchase. But that's not it. We can even take it one step forward and create a chatbot kind of an interface. So in order to do that, let's first create a chat history which is currently blank. And then we are going to iterate, right? So while the loop hasn't ended, so first thing that we will do is we'll ask the user for their inputs. Right? So here we'll ask the user what your input is and we'll first check if the user input is basically exit. If the user wants to exit, that is the user wants to exit the chat, we'll just print exiting the chat and we'll break out of our loop. If not, we are going to generate the response from the large language model by using the function that we have defined previously. The inputs will be the user input that we have currently received and the current chat history that has been generated. And then let's also print the user input as well. Right? Here we'll print the user input and the corresponding AI input as well. And for the AI response, we'll use response.content. Remember, this is basically an AI message object that we will get. In order to get the text response, we'll need to use the content attribute within it. So I'm going to use response.content to print the content received back from the AI model. And finally, I'm going to append within the chat history, firstly my human message, which is basically generated from here. And finally, we'll also append our content which we are getting back from the model. So here we'll just respond with the response here because response already is an object of class AI message, so I do not need to wrap it again. So here what we have done, we have successfully created a loop that's going to wait for a user's input, verify if the users want to exit the chat, print if it's exiting, otherwise get the response back from the large language model, print what the current user inputted, print what the AI response is, and finally append it within our chat history in order to continue the loop. Let's see this in action as well. So here as you can see, it's waiting for my input. Let's say I want to know the refund window. So here as you can see, I gave a response which is basically I want to know the refund window and the AI has responded back saying customers may request a refund within just 30 days of purchase. Let's continue and let's also ask what's the customer care email address. So let's type it again. What's the customer service email address? And you can see here after writing it out, it is basically saying that the customer care email address is basically support@example.com, and you can go back and verify whether this is right or wrong. It's actually the same email address that we have provided within our prompt template as well. So now if we are done, we can simply type out exit and that will essentially exit the chat saying that we are done with our chat conversation. So as you can see how easy it is to use LangChain to develop a RAG based chatbot agent. That's all for this session. In the next session, we will start with the agentic framework using LangChain. So I'll see you in the next class. Thank you very much. Hi everyone. In this session, we are going to start discussing about the agents and tools using LangChain. This will allow us to create smart LLM applications which can automatically decide which tool to call in order to generate an accurate human response. Let's get started. So let's begin by talking about what is an agent. An agent, as I mentioned, is a smart LLM application. So what an agent can do, an agent can look at an input prompt from a user and this prompt will be evaluated by the agent, right? So here you can see the user will give a prompt and the prompt will go to an agent. Consider an agent to be like a middleman. So depending upon what the prompt says, an agent will evaluate it and see what the user wants to do. Is the user asking for a certain research to be performed, or are they asking us to create an image, or are they asking us to evaluate or let's say calculate a complex expression or a mathematical expression? So depending upon what the prompt is asking, the agent is going to call the respective tool. So there are different tools which will be defined, and each tool will perform a single activity. So there could be one tool that is doing image creation, a second tool that is doing research, a third tool that is performing calculations. So depending upon what the prompt says, the agent will evaluate it and redirect the response to the correct tool to get the right answers. Right? So the workflow for an agent looks something like this. It begins by giving a prompt to the user. The user prompt is evaluated by the agent, and then the agent will call the corresponding tool. Right? So there could be one tool called calculator that is calculating our responses, a tool that is researching a Wikipedia page to get the final output back. And depending upon which tool is called, we'll get a result and the response will be formatted by the agent for us. So for this demonstration, we are going to create two tools. The first tool is a calculator tool that will be used for performing or evaluating mathematical expressions. And the second tool that will allow us to perform research using Wikipedia articles. And based upon the user response, the agent will decide which tool to automatically call and give us the accurate answer back. So let's get into the Python and see how to implement such a agentic framework using LangChain. So here I am inside my Jupyter notebook, and as always, we are going to begin by importing our dependencies. We'll load our environment variables using the load.env function. The chat OpenAI will allow us to create a large language model that will be used for evaluating our user expressions. LangChain.agents give us access to the classes for creating an agent executor, and another function that will allow us to bind all the functionalities together. So here the create OpenAI function agent, this particular function will allow us to use the LLM as an agent, right? So as you can see here, it will ask us which agent to use, and depending upon, since we are using an OpenAI agent, so here we need to use the OpenAI function agent to call the respective functions within OpenAI. And finally, we'll import tools to define our individual tools. And lastly, Wikipedia import is required. You can install the Wikipedia package. It's open source, and this will allow you to access the data available on Wikipedia's databases. So all of these packages are required. If Wikipedia is not there in your machines, you can simply run the command pip install Wikipedia to easily install these packages. So let's first begin by loading our environment variables. So as always, we'll start by loading the .env file. So once our environment variables are loaded, we are now ready to create our tools first. The first tool that we'll define is a calculator tool. This calculator tool will take an expression as an input. This expression will be of a string format, and it's going to evaluate the results and return us the string back. Now how this particular tool is going to work? This tool is going to evaluate, right? So for evaluation, we'll use the eval function in Python. This eval function is going to evaluate our expression, and the result of this expression will be stored in a result variable right here. And since all the expressions might not be right, so what we will do, we'll wrap this inside a try catch block. So here what we have done, we have defined a calculator function that takes an expression as an input. It will evaluate this expression and calculate a result. If it is able to evaluate this expression correctly, well and good, otherwise will return an error saying that this particular message could not be evaluated. Right? So whatever the error will be, that will also be part of the value. Now in order to convert this into a tool, you have to decorate it with the tool decorator which we have imported above. This decorator has to be created in order to convert this function into a tool that we'll use for our agent's evaluation. Now one thing which is missing in this particular case is a doc string. Now doc strings are very important for you to define in this particular case. With the help of doc strings, the large language model will understand what is the use or the purpose for this tool that you have created. Always remember, it is mandatory to define a doc string whenever you are creating a tool function. Without the doc strings, these tools cannot be evaluated. So they give LLM ability to understand what exactly this function is getting used for. So at the top, we give a doc string which says tool for evaluating mathematical expressions. Then we are trying to evaluate our expression and returning the result back. And if any exception occurs, we are returning the string containing the exception itself. Similarly, let's define another tool. Let's call this tool as Wiki Summary. And this particular tool will take input a string, right? So here we'll give a topic for Wikipedia to summarize. So in this particular case, a topic will be given as an input, and it will try to research on Wikipedia articles and return us back a summary of those topics. As always, I am going to provide a doc string first that explains what this tool is getting used for. Here we are saying this tool is meant for getting the details of the topic from Wikipedia. And then finally we write a try catch block, and here we are using the Wikipedia package, calling the summary function and asking it to summarize this topic in 2 sentences. So here you can see we are getting the summary within 2 sentences, and whatever summary we will get, we will return that summary back to the calling function. Now you can see here I have again wrapped it within the same decorator called tool. So here we have created 2 simple tools, one to calculate expressions and second to summarize articles meant from Wikipedia. Let's now combine these tools in a single list. So what we will do is we'll create an object called tools, which is basically a list of tools that we want to use. And next up, we are going to define a large language model here. This large language model is going to be used for evaluating our expressions. Okay, so here the API key has to be loaded, so I'll just load it from my environment variables list. So here we have created a list of tools to use, and secondly we have created a large language model that will allow us to evaluate the user inputs. Next up, we have to define a prompt, right? So now it's time to create our prompt. Now here we are going to use again the chat prompt template .from messages feature. So this particular function within chat prompt template allows you to create a simple template. Now here we have to remember 3 things. The first one is a system level prompt. The system level prompt will basically tell large language model what it needs to do. Here we are saying you are a helpful AI assistant that can use tools to answer the user's questions. So here this chat prompt template we need to import as well. So let's quickly import it here. Right, so we are going to import our chat prompt template and our messages placeholder as well. After we have imported these two, you will see that we are able to use them below. So system level prompt is basically that you are an AI assistant which is going to use tools to answer the user's questions. Followed by the input that the user has provided, the user is going to give certain input. And lastly, this is something which is very unique for agents. So here we will see whenever you define prompts for agents, you need to provide a placeholder for agent scratchpad. So what this agent scratchpad is, it's basically a placeholder that allows agent to think and improve itself. So obviously the agent is going to do a lot of reasoning before deciding which tool to use. And the scratchpad is basically the place where agent will put all of its thinking and try to see which is the exact tool to use. Okay, consider it to be a default placeholder that you have to keep whenever you need to define a prompt template for an agent calling. So now our prompt template is also ready. Next up, we are ready for defining our agents. So let's define an agent here using the function create OpenAI functions agent. So this particular function will take the LLM as an input. So remember, this is the large language model that we have defined. It will also take the tools that this large language model has to process and the prompt that it needs to use in order to give the right answer. So all of these 3 have to be tied up together, and therefore we are using the create OpenAI functions agent to create an agent right here using the OpenAI functions agent call. We'll basically create an agent executor as well. This agent executor will take our agent tools and essentially execute our agent in order to get the right response. So think of it as a chain that we are defining, which will help us to define a graph and invoke the agent depending upon which tool it has to use. Right? So this is our agent that we have created, and this is basically the executor that will execute the agent depending upon the user input. So let's first recap what we have done until now. So we started off by defining our 2 tools. Remember, one tool to calculate, one tool for summarizing. Right? Agent will decide which tool to use depending upon the input response. Right? So if you are asking it to evaluate some mathematical expression, it will call the first tool. If you're asking it to summarize a Wikipedia article or any topic in general, it will use the second tool. We are combining those two tools together into a single list of tools that we want to create. And here we are defining a large language model, which will be the agent model that is going to be called. The prompt template allows us to define how the agent has to function. The system level prompt here is saying that it's a helpful AI assistant that can use tools to answer the user's question. We are then defining the input that the human has provided and a placeholder for agent to think within itself. Then an OpenAI function will define an agent for us using the large language model defined above, and the executor will help us execute this agent using the input query that the user has given. Now all that's left to do is define a chat interface that can help us to interact with our agent using the inputs. So let's do that now. Let's define a simple loop, and the first thing that we will do is we'll ask the user an input. Right? So this user input will be written here. And once the user has given an input, we are going to use the agent executor and invoke our agent by passing the user input here. Right? So remember, this user input will go to our agent and the agent will be invoked over here. And before that, we'll first check if the user input is exit. If exiting, then we'll break out of the loop. If the user input is not to exit, we'll basically call the agent executor right here. So once the agent executor is done running, it will return us a response back, and this response will be printed right in this fashion, right? So we'll call the output to get the output that has been returned to us by the agent call. So let's run this and see this particular tool in action. Let's write a simple expression. Tell me the result for 4 times 5 plus 10. So you can see here it is logging us as well. It's saying that it has invoked the calculator with expression 4 into 5 plus 10. And here it was also showing you the result as well. So the result of this expression is 30, right? So 4 times 5 is 20 plus 10 is 30, that's correct. And here you can see once it has finished, it is also telling you the output as well. So the result of the expression is 30. So whatever expression you had passed, it has evaluated that expression and the answer for this question has been given to us as 30. Let's ask another question. Let's say, who is Nikola Tesla? So now this time, depending on our question, it has seen that we want to get the summary. So therefore it has automatically called the wiki summary tool, provided the topic as Nikola Tesla, and basically Wikipedia has responded back with this text, and here you can see it has summarized the answer back to us. So Nikola Tesla, this is what the lifespan of that person was. He's a Serbian American engineer, futurist and inventor, and other things about Nikola Tesla as well. So over here what we have done is we have given two different expressions to evaluate, and based on the user input, the tool itself was invoked based on the agent's evaluation of the expression, and finally we got the result back in this fashion, right? So these results are returned back to us via the agent call itself. Let's also pass another prompt, but this time the input will contain both. Tell me about Nikola Tesla and answer the expression 2 plus 40 multiplied by 3, whatever, right? So here we are asking it to do two things simultaneously. So in this single expression, we are asking the model to first tell us who Nikola Tesla is, and also we are asking it to evaluate an expression. Let's see if the model can accurately identify that it needs to make two different calls. So here, as you can see here, first of all, it called the first API, which basically you can see that all the logs are printed here. So first of all, it essentially called a wiki summary to get the summary for the Wikipedia article from Nikola Tesla. And second, it automatically identified it needs to make one more call to evaluate the expression as well. So here, whatever expression we had passed, it evaluated that expression and answer was 122 as well. So as you can see, even though we had given a single response, we had given a single user query, but that user query contained two instructions. And both those instructions were identified by a large language model, and to evaluate those individual instructions, LLM made a corresponding tool call to give us the right output. So all these questions that we had asked were successfully returned to us back by the agent. So it was able to evaluate an expression, tell us who Nikola Tesla was, and also return us a response when the prompts were actually combined, right? So we had two expressions wherein we wanted to know two things simultaneously in a single expression. So basically in this session, we have successfully built an agent using LangChain. In the last session for this, so in this session, we have successfully built an agent using LangChain. In the next session, we are going to combine all the previous concepts and essentially create a Capstone project that will allow us to create an agent using RAG as well. So I'll see you in the next lecture. Thank you very much. Hi everyone. In this session, we are going to create a simple Capstone project that will allow us to combine all the previously learned topics together. Here, we are going to use the concept of RAG, agents and tool to create an HR assistant that can answer questions for each and every employee of an organization. Let's see what project we are trying to create here. So in this, the goal is to essentially query different offer letters of each and every employee of a company. So imagine having a chatbot that can take your offer letter, and if you have any questions pertaining to your offers, it can read that offer letter and give you the answers from your specific offer. Right? So it will be able to answer some frequently asked questions, and also it will be able to compute the total salary. Right? So in this particular project, the tech stack that we are going to use will use FAISS as a vector store for retrieving and embedding our documents. The large language model will be GPT-4o Mini that will allow us to interact with the underlying large language model. We'll define tools to calculate salary and answer some frequently asked questions as well. So there will be two tools, one which will be used to calculate salary and the second tool that will answer the questions other than the salary calculations. And last but not the least, we'll combine everything together inside a LangChain workflow. So this particular agent will be first able to read the offer letters which are retrieved by the RAG, compute the salary and also keep a track of the conversation that we had with the employee of that specific company. So for this chatbot, we can ask different questions, such as, first of all, we can ask the model, how many days off do I get? How many leaves can I get? What's my total compensation? What's my work schedule? Right? So all of these questions can be answered by looking at the offer letter for that specific company. So without further delay, let's implement this project in Python. So as always, we are going to start by importing our dependencies first. So here you can see we are first importing the load.env to load our environment variables, chat OpenAI to create the large language model for interacting with the customer, or in this case, our employees, Hugging Face embeddings to embed each and every offer letter that is pertaining to each employee. We'll also use the text loader to load those documents and embed it inside our vector store. FAISS is our vector store this time. The prompt template here will allow us to templatize the input prompt that will set the user instruction for the model, the system level instruction for the model, as well as the input or the offer letter for that specific employee. And the messages placeholder is required to keep a track of the previous chat history. Agents, we are going to use create OpenAI functions agent because we want to define an agent using OpenAI, and an agent executor to execute that respective agent. And the tools will allow us to define the tools one by one. So first, let's take a look at some of the offer letters that we have available. So in this particular demonstration, we have 6 or 7 offer letters, and each offer letter basically contains basic information about an employee. So here we have details like an employee code, what role this employee is currently working at, what's the work location, what are their work hours, the annual leave policy, what's the fixed compensation, and the corresponding performance bonuses. So here you can see all of this information is part of each and every offer letter that is present here. This is for employee who is working as a developer, employee code is 102. This is for a data scientist, employee code is DS105. This is for HR, employee code HR103, and so on. So each and every employee offer letter contains certain fixed compensation and a performance bonus. So the goal here is to basically use a salary calculator that can first of all combine these two together and calculate a total compensation by multiplying the compensation and the percentage and giving you the final answer. So over here, first we'll start by defining our tools one by one. Right, so we'll first begin by defining our tool. So let's create the first tool, which is called salary calculator. So for this salary calculator, we are going to define two inputs. The first input is going to be the base package. What's the base salary? So in this case, this base salary will be the fixed compensation that we are going to get. So in this case, this fixed compensation here is $85,000. And secondly, we'll also need the percentage of the fixed salary, that is essentially the variable component. right? So all of this information will be returned to us by the large language model. So this tool is going to take the percentage and the base salary as the two inputs in order to proceed forward. So let's rename these input parameters. Let's call them base salary and bonus percentage itself. And then next we are going to define a doc string that is going to contain what this particular tool does. This particular tool is calculating total salary by adding the base salary and the bonus amount. And how are we going to extract these? So remember that these base salary and percentages will represent string because there will be a dollar in front with a comma in between, and percentage also will have some special characters. So we will need to pre-process these strings first before we can multiply or add them together. So what we will do here is basically we'll first take the base salary and we'll replace the dollar symbol with an empty string. So all of these dollar signs that are part of the text strings will be replaced, and we'll only have basically the numbers available, and also will replace all the commas in between. So there could be commas there as well, so we'll replace comma and dollars so that we are only left with numbers, and then we'll convert those strings into float, right? So we'll have the base salary in that fashion. Similarly for bonus as well, we multiply our base with the percentage but after stripping our percentage sign. So remember, in the percentage as well there will be a percentage sign towards the end, so we can easily strip it using the strip function, and then whatever float is there, we'll multiply that with the base salary and to calculate here the bonus of that particular employee. And total salary is going to be the sum of base and bonus combined. So once this is done, we can return a string which says the total salary we have already calculated here, the base salary which has been extracted above, and the bonus that we have extracted, right? So all of this combined together will give us the total salary back. And we can then write an except block if a particular exception has occurred. So here we'll say basically return error calculating my total salary. So for this particular tool, we'll then wrap it inside our tool decorator to make sure that this tool has been successfully created. This is the first tool that we have defined, which easily calculates the salary based upon the inputs of base salary and bonus percentages. Next up, let's define a second tool that can answer all the other general HR related queries. So remember, this particular tool will be called only when you are computing the salary. For all the other questions, this second tool will be called, and this second tool, the description as you can see, this tool says this is answering general HR questions based on the employee's information, right? So for this tool, again, we are writing a try catch block. Now remember that this particular tool, the answer for these questions will already be coming from the large language models only. This tool is only meant to return back the responses back to the user. Alright, so we are not performing any calculations here. We'll get the employee information that is requested and we'll return that employee information in this particular fashion, right? So if you do not want to return the query back, I can even remove this part. And I will simply say that based on the employee information, whatever employee information has been requested, it will be returned back to the user itself. So in this particular tool, we are answering any HR questions, and the response which we will get from the large language model will be returned back to the user in this format which is written here. And then we'll accept the exception here, and if there are any particular errors present, in that particular case, we are saying that error processing the query that was given to us. And then we'll combine these two tools together. So let's do it in another line. So let's define all of our tools, right? So we'll combine these two tools together. So we'll define a list that contains both of our tools that we have created. The first tool to calculate our salary, and a second tool to answer any other HR questions that a particular employee could have. Now, after this, we have to basically load our documents. So remember, all of these individual documents, they have to be loaded into a vector store so that we can retrieve it using RAG. So for doing this, what we are going to do is we are going to iterate through each file, right? So what I will do is I'll iterate through each file and load and append that into a doc list. So first, let's create a list of input documents. Then we are going to iterate through each file in our current working directory. So for listing the files, we can use the function os.listdir, right? And this will basically list all the files in our current working directory. And we'll check if the file is ending with .txt. Remember that in this folder, there are other files as well. We only want the files that are text files, right? So all the files that are ending with .txt, I'm using those files only. So what I will do is I'll basically take that file and I will create a loader by using or loading that specific file, and whatever file has been loaded, I'll append that file in my input documents list, right? So I will extend my input documents with the new file that has been loaded here. Okay, so now what this will do, this will allow me to load all of the input documents easily. So I can print my input documents list to verify whether all the input documents have been properly loaded. So as you can see, in my current working directory, there are 5 offer letters present. So all of these 5 offer letters have been successfully loaded, and the corresponding information for each offer letter is also present in the respective file. One thing you would have noticed here is this time I am not using any chunking as such, because these offer letters are sufficiently small and we do not need any chunking, because we want all the information pertaining to an employee part of a single document retrieval. To make things simple, we are not chunking it for this particular demonstration. But if you wish, you find the offer letters are too big to be inserted in one go, you can use chunking as we have demonstrated in our previous demonstrations. So now we are ready to embed these documents into our vector stores, but before doing that, we need to create our embeddings model. For embeddings, we are again using Hugging Face embeddings model, and once our embeddings have been defined, we are ready to define our vector stores. So for a vector store, we are using FAISS. We are going to load the documents, pass the input documents that we have created in the embedding model to embed these documents inside our vector store. Next up, we are going to define a retriever that will retrieve the documents which are matching the user's input. So let's quickly recap what we have done until this point. Till here, we have defined both of our tools. One tool to compute salary, second tool to answer all the other questions except for salary calculations. We are combining these tools into a single list. We took all the offer letters and ingested it inside a single vector store, which later will be retrieved using the retriever that we have defined over here. So up until now, our vector store is ready and our tools are ready. Now it's time to implement the agent. So in order to implement the agent, the first thing that we will do is define our large language model itself. So the large language model here is basically GPT-4o mini, and we need to define our API key as well. This API key is basically going to be generated from our environment variable itself. And secondly, we are going to define our prompt. Now the prompt is very important again, because this prompt is going to contain a system level instruction that will tell large language model what it needs to do. So for this large language model, this is an HR assistant who is going to provide the employee information depending upon the employee information provided below. Right? So here you can see I am clearly asking the model to provide the information and answer the question by looking at the below present context. This context is the retrieved information for that specific employee. Human is going to contain the instruction that the user has given, and finally a messages placeholder to basically work as a scratchpad for our agent. Remember, in this last class I have mentioned that a scratchpad is the place where agent is going to perform its logical reasoning. Alright, so whatever the agent thinks, all those inputs will be provided within the scratchpad for the agent to use. This is mandatory whenever you are using an agent invocation. So we have defined our prompt, we have defined our large language model as well. So now let's basically begin by asking the simple questions to an user here. Okay, so before that, let's define our agent as well. So here we'll call the OpenAI functions agent, and we'll tie up LLM, tools and prompt together. We'll define our agent executor as well. This agent executor will be able to execute our agent on the mentioned tool, and verbosity here is mentioned as true so that we get to know what the agent is doing one after the other. Okay, so here if you set verbose to false, it will not show you its interim thinking, it will just give you the responses that you have requested. So over here we have defined our agent, and we have also defined our executor that will execute the functions that we call it to do. So now we are ready for invocating our agent. So first thing that we will ask the model is first thing that we will ask an employee is their employee code. So let's define a variable to store our employee code, and we will say input your employee code. And what we will do is we'll retrieve our employee's information by calling the get retrieve or get relevant documents by the employee code. And in order to retrieve just a single document back, because we need just one document for each employee, which is the most relevant one, so I will set the parameter k to 1. This will just retrieve the top matching document only. It will not give me more than one document. And finally, once this document has been retrieved, let's just play it once and see if the answers which are getting are correct or not. So what I'm going to do is I'm going to pass in this particular employee code, which is ANL 104. And after that, let's see if we have correctly, identified the right document or not. So you can see the retrieved document that we have received. For that retrieved document, the text or the file name in this particular case is anl104.txt, which is correct, right? And the content for this particular page is also basically containing that employee's information only. This particular functionality will be able to retrieve the information for each and every document, right? And once we have the information, now we are ready to answer any queries that a particular employee could have. So then let's quickly define a loop. In this specific loop, we are going to ask the user their specific queries. So in this particular case, we are asking the user what are your questions that you want the answers to happen. And then finally, we are using the agent executor to invoke our agent. The input which we are passing is the query that the user has entered, and the context that we have already loaded is essentially the employee info that we have created above. And once the result is back, we are going to print the response back that we are getting as an answer from the model. All right, that is basically the flow that we are currently going to follow. All right. So let's execute this. And now let's ask some simple questions to the model. So for this particular employee that we have retrieved the document, which is essentially the employee code PM101, ANL104, right? So let's ask few questions. So which role am I currently working at? So in this particular case, this will enter an agent information, and you can see here, based on the information for this employee, all of this are available. And for this particular role, it is basically saying that the role which I am currently working at is a business analyst role. Okay, so here you can see you are currently working as a business analyst in this company. Let's ask another question. So let's ask, what's my total salary? So this time, this particular function has been invoked, and here you can see the base salary is asked to be at 95,000, and the percentage is basically at 11%. So here you can see it is multiplying it together. So 95,000 and whatever 11% of 95,000 comes out to be, it is adding these two together to calculate the final answer. And you can see the finished response that we get, your total salary is $105,000, $105,450. Let's also continue and let's ask the model, what are my working hours? So this time again it is going to invoke, and based upon the input that the model has received, you can see it has correctly answered that the working hours are from 9 AM to 5:30 PM. Let's also ask, what's my work location? So you can see here, this time based on the employee information, the work location that we have been identified is Boston. That actually is correct, right? So as you can see, it's very easy for this particular model to answer all the relevant questions looking at the context that is present inside our employee's information file. So in this particular hands-on demo, what have we done? So we basically have successfully built our own AI assistant that can retrieve the relevant information for any given employee from looking at their employee code. And then whatever information is present within that offer letter, it is able to answer all the relevant questions for that employee using that particular context that we have added. So I hope this entire journey has been helpful for you to understand the different components of an agentic framework, agents, tools, RAG, etc. Thank you very much. I'll see you along. And that's a wrap. This was a final session of our Gen AI learning series, and we've loved having you along for the ride. If you found this series helpful, remember to hit that subscribe button and give it a thumbs up. It really helps us out. Also, if you are looking to level up with globally recognized certification in automation testing and Gen AI, check out our StarAgile certification programs. The links are down in the description. Thanks for watching and keep learning. I'll see you in the next one.